good afternoon, konnichiwa. Greetings from Fukuoka, Japan. My name is Human Farzaneh. I'm an associate professor at the Interdisciplinary Graduate School of Energy Science, Kyushu University. On behalf of the organizing committee, it's my great pleasure and honor to welcome all of the distinguished speakers and participants, professors, researchers, students to our today's webinar entitled Aligning Climate Change and Sustainable Development Policy in Asia. We are very grateful to the Kyushu University platform for inter and transdisciplinary research for providing technical and financial support to this workshop. This year, we are also fortunate to have the support of the Ministry of the Environment, Japan, MOEJ, Institute for Global Environmental Strategy, I²CNER, the Japan Committee for I²CNER, and Asian Co-Benefits Partnership. We are very grateful for the all support from these sponsors. As you know, the title of this workshop is the same as the title of the book that we recently published and will be available online by the end of the March 2021. So the invited speakers of this workshop basically are the co-author of different chapters. And the main purpose of this workshop is to discuss the, the content and the chapters of this book. In addition, we have two distinguished participants and speakers, Dr. Clement from I²CNER and Professor Saboui from Sharif University of Technology, Iran. So to start the workshop, I would like to invite Mr. Toshiyuki Yamazaki, the Director of Office of International Cooperation in Air and Water Quality Management, Ministry of the Environment, Japan, for welcoming remarks. Mr. Yamazaki, thank you very much for accepting our invitation. The floor is yours. Could you please share your screen? Yeah. Thank you very much.
Hi. Good afternoon, everyone. My name is Toshiyuki Yamazaki, Director of the International Cooperation in Air and Water Quality Management, Ministry of the Environment, Japan. On behalf of MOEJ, I'm pleased to welcome all of you to today's workshop. At the outset, I would like to express my gratitude to all of you, namely Kyushu University, I²CNER, I²CNER, ACP, and everyone who have put their precious time for preparation and make this workshop happen, and all the participants to join today, despite of the global pandemic situation. Last year, Japanese Prime Minister Suga delivered his policy speech and highlights carbon neutrality by 2050 as one of the most important keys of growth, both for environment and economy. MOEJ will take the most important role to conquer the goal. MOEJ has been taking a co-benefit approach and been implementing projects through bilaterally and multilaterally, especially in Asian regions. Accelerating co-benefits approach leads to reduced pollutants such as NOx, SOx, VOC, and greenhouse gases for climate issue, which then leads to improvement of health and well-being, as well as contribution for the SDGs. Today's workshop will be a great opportunity to deepen your understanding of the concept of co-benefit and realize the importance of developing its initiatives in Asia for making sustainable development. I'm very thankful to have this opportunity and look forward to your presentations. Thank you very much.
Okay, thank you very much, Mr. Yamazaki, for the nice words and also welcoming remarks. We really appreciate the great support from the Ministry of Environment for the project that we have at Kyushu University in collaboration with I²CNER. So let's move to the next session, which is introductory session. The keynote speaker of this session is my colleague, Dr. Eric Zussman from I²CNER. Eric is the senior researcher and area leaders at the Institute for Global Environmental Strategies, Japan. And he's expert in climate policy and co-benefit assessment. So he's also the leader of a co-joint project between I²CNER and Kyushu University. So Eric, I would like to ask you, please share your screen and also please turn on your camera.
Okay, thank you, Dr. Human. Can you see me?
Yes.
Great. Okay, thank you very much, colleagues. It's a great honor and privilege to be here. And as Professor Human noted at the very beginning of our workshop, we're going to be focusing a lot on a book project that colleagues from I²CNER, Kyushu University, the Korea Environment Institute, and Beijing Normal University contributed to. The title of that book project is Aligning Climate Change and Sustainable Development Policies in Asia. And it focuses very much on this concept of co-benefits. The book will be available for purchase in March, and you can actually purchase ahead of time if you'd like, but please get in touch with the organizers if you're interested in a copy. So my job today really is to frame the discussion for the rest of the workshop. And to do that, I would like to go back to several key developments that have occurred in terms of international climate negotiations and international negotiations on sustainable development. And the first key milestone in that regard was the Paris Agreement. So for those of us who have been following the international climate negotiations, you might already know that 2015 was a point that could actually potentially change the way that countries respond to climate change. This is partially because we've seen a continuing shift towards more of a bottom-up structure in terms of climate negotiations. That is, countries are now being asked to submit nationally determined contributions that reflect their own developmental circumstances. And this is a lot different than, for instance, climate change negotiations even, let's say, 10 or 15 years ago, where the emphasis was on targets and timetables that were negotiated at the international level with the national leaders. This is much more of a bottom-up approach. And because of it's much more of a bottom-up approach, it also creates opportunities to strengthen linkages between climate change and sustainable development. Those opportunities are particularly important as we think about ways that countries can reduce the costs of mitigating climate change, and also to try to use the title of our talk today, our workshop today, to align their development priorities with climate change. Now, the other key development that we've seen since 2015 is the Sustainable Development Goals as a part of the new development agenda, the 2030 Development Agenda on Sustainable Development. Now, as many of you might know, there's 17 of these goals, including SDG 13 on climate change. Moreover, there's 169 targets that are embedded within these goals and approximately 240 to 250 indicators that are paired with those targets. What has happened with the SDGs is not only consequential because it has a broader structure than previous development agendas, covering more issues. What makes the SDGs so impactful, I would suggest, is it really places a strong emphasis on making linkages across different development issues. And so, for instance, for SDG 13, there's a growing interest in making linkages between that SDG and, let's say, SDG 11, which focuses on sustainable cities, or maybe SDG 14 or SDG 15, which focus on life below water and life on land. All of these SDGs are closely related to each other. And now I think there's a growing opportunity for policymakers to make linkages between these SDGs in their big policy decisions, but also some of the narrower practices that we see on the ground. And we'll see some examples of this throughout our workshop today. Now, this gets us to an important question. That question is, okay, we're beginning to see the world in terms of more of these interlinkages across different development issues. So for instance, to highlight a particular important linkage that we'll talk a lot about today between air pollution, health, climate change, that might even have some ripple effects over onto water insecurity. We're increasingly seeing these linkages, but how can we really actualize them? How can we really operationalize this more integrated approach? And what I would suggest to you is that the work on co-benefits, it's gone on for approximately 3 decades, can offer some useful lessons and provide policymakers with decision-making tools, as well as insights into the different types of policies and institutional arrangements that are needed to actually integrate multiple development issues together. And so to understand this, what we begin to do in this book is first we highlight that there's been some shifts and changes in the way co-benefits themselves are viewed. I mean, when the co-benefits work first started coming out, the first article on co-benefits was published in 1989. There was a very strong emphasis on developed countries, and in particular, carbon taxes or emission trading schemes that were very much climate policies and how they would potentially impact air pollution and health, but once again, largely in a developed country context. And so what began as a sort of concept quickly moved into an approach to doing research. And there was a lot of modeling work done, especially in preparation for the 3rd assessment report for the Integrated Panel on Climate Change. This is the big authoritative report from the IPCC. A lot of research was done using energy models and health models to understand what would be the value, for instance, of reducing a ton of carbon through an emissions trading scheme in the United States, in Europe, in Japan. What would be some of the side benefits in this case in terms of air pollution and health? And it was possible to look at and monetize actually what would be some of these side benefits. And the important thing to take here is these side benefits were critical to policymakers because when they're trying to persuade leaders, politicians, of investing in climate mitigation, one of the big concerns is climate mitigation generally delivers benefits that are long-term, global, and relatively uncertain. So if I invest, for instance, in a renewable energy power plant in Hanoi in Vietnam, well, that's going to have benefits that are accrued to the global climate, and those benefits are not clear it's going to actually benefit Hanoi, and those benefits are likely to come in the long term. So how can we change that calculus? How can we link the climate benefits to something that's near term, something that's local, and something that's relatively certain? And the way to do that, emphasizing this initial view, was to aim for some of these additional co-benefits. And this diagram, this Venn diagram, has been used many ways to sort of highlight the sweet spot. We try to get the overlap between these issues. Now, what's happened since this concept initially originated approximately 30 years ago, and the modeling work that grew out of it, was a growing attention to how it might be applied in a developing country context. And what's happened with this reorientation is a greater emphasis on other sectoral policies, environmental policies, economic policies, social policies. And these entry points might deliver some mitigation of climate change as a co-benefit, as a climate co-benefit. So this approach begins to invert or change our perspective on the different opportunities and different channels for achieving co-benefits. And this might make more sense in a developing country context, because for many developing countries, climate-only policies do not make a lot of economic sense. We need to make sure that they deliver on immediate development priorities. So for some of the same reasons, we want to make these benefits more local, more immediate, more certain, but moving through different channels and options, the co-benefits perspective began to reorient itself. And so we see this reorientation here in the slide, where we see development policies as sort of a broad category for different entry points, and climate co-benefits as your sort of other desirable results that you would want to get from different types of measures and policies. Now, the sort of third turn that we've seen in the work on climate change reflects the growing interest from the air pollution community. So first we had sort of a climate perspective, then we had a development perspective. Now, more recently, over the past 10 years, we've seen growing emphasis on certain types of air pollutants that when you mitigate them, they lead to reduction in near-term warming. So warming that could appear anywhere between 7 to 14 days up to about 10 years, as well as improvements in local air quality, as well as improvements in crop yields and public health. And this type of air pollutants that fit in this category, they're known as short-lived climate pollutants. They include things like your black carbon, which is a part of the PM 2.5, which is a big problem in Asia and tends to come from, for instance, cooking on open stove or from diesel vehicles. So it includes black carbon. It also includes tropospheric ozone, which is actually a secondary pollutant that is formed from the mixing of sunlight with other primary pollutants like NOx and VOCs. And so this tropospheric ozone poses a problem for climate change in the near term, and it also is not so good for our health or for infrastructure for that matter. So this air pollution perspective focused on, in general, sort of smaller scale interventions than either of the two, development or climate perspective, and on a subset of pollutants, that's black carbon, tropospheric ozone. It also includes things like HFCs and methane. We group methane in with short-lived climate pollutants. It's also considered a greenhouse gas, but we group it in there with short-lived pollutants because it's only up in the atmosphere for about 10 years. Okay, so we have these different perspectives. Now, what I would suggest to you moving forward is that these different perspectives are quite useful for policymakers that are thinking, okay, I have my SDGs now. I also have my climate change negotiations going on, and I'm working on my NDC. How do I bring them together, and how do I concretize that link in a way that makes it very persuasive to politicians who might not be so aware of these linkages? And so what I would suggest for you is that the book that we're working on and that we're going to be presenting some research from today can help to sort of advance this co-benefit approach and help integrate it into key decision-making processes. And that's because the book is divided up into 3 different sections. So the first section of the book is going to talk a lot about different types of tools that can be used to quantify co-benefits. And those tools are applied to interventions like a heat-only boiler in Mongolia, a project that the Ministry of Environment, Japan, supported, and now we have a tool for it. They also involve a tool that's been developed by Dr. Human's lab on an urban sustainability index. So looking at the case of sustainability and climate change linkages at the city level. So tools are going to be definitely one part of the equation. And I think this is one of the areas where we made a lot of progress. Another area that we need some attention is actual case studies that demonstrate how these different tools or the co-benefits logic can really be applied. And so we have some case studies from Korea, from Japan, and from China, all focusing on renewable energy and some of the co-benefits that come from investing in renewable energy in those 3 countries. And these case studies not only present how the co-benefits are quantified, but they also discuss some of the barriers to actually achieving the co-benefits and how those barriers can be overcome. Now, the third set of presentations is going to focus on new perspectives on co-benefits. And when we say new perspectives, what we're going to do is look through a slightly different lens at some of the opportunities to achieve co-benefits. And so this will include presentations on, excuse me, presentations on biodiversity co-benefits, as well as what we call social co-benefits from empowering different stakeholders and social groups. And then last but not least, one of the key things to actually take the co-benefits approach forward is to think about the technologies that we need to transfer, especially from developed to developing countries. And so we have a discussion of this process of co-innovation that can help deliver co-benefits. And this co-innovation process, I think, will be very important for actually setting up the means of implementation for delivering on co-benefits. So as you can see, we have a very full and enriching agenda ahead of us. Many of the chapters that I just touched on briefly there will be presented in more detail throughout our workshop. And as Professor Human mentioned, we're also going to have a keynote speech from Zig Kleinmont at IASA. And we look forward to engaging with you over the next few hours as we present some of the key results of our research. Thank you very much.
Okay, thank you very much, Eric, for the nice presentation, and thank you very much for the comprehensive, explanation about the detailed program of this workshop. I really appreciate. So now the floor is open for some quick and short question. If there are some questions from the keynote speakers and participants, we can have 1 or 2 questions. If you have a question, please turn on your mic and ask your question. No question? Okay, so if there is no question, then we can move to actually the first session of this workshop. And then Dr. Zussman will moderate this session. Eric, can you please continue using your screen? Webcam. Yeah, thank you.
Okay. Yeah, so thank you very much, Dr. Human, for allowing me to introduce the next speaker. So our next speaker is Professor Yadullah Sabuhi. He is a professor at the Energy and Engineering Department of Sharif University of Technology in Tehran, Iran. He was the founder and director of this research institute, and he has supervised dozens of PhD students and led a wide range of international and national projects and contributed to important publications that often have an integrated or interdisciplinary perspective, sometimes combining science, technology, economics, and policy to enhance the understanding of and policy responses to transitions to sustainable low-carbon energy systems. So what I'd like to do now is to yield the floor to Dr. Yadullah. Dr. Yadullah.
Mr. Zussman, thank you very much. And I thank you all the gentlemen or ladies who are taking part in the workshop. If you allow me, I will share my screen and then start presenting my talk. Do you have my share by screen?
Yes, we have yours, yeah, now it's okay. So please full size the screen.
Yeah. Dr. Human and Dr. Zussman, I would like to thank you for giving me the opportunity to take part in this workshop. The point is that I'm going to present this co-benefit of energy efficiency and environment in Iran. And I will highlight this co-benefits by stating an example and the structural changes that should happen in the Iranian energy sector. I'll try to present briefly, very short, energy situation in Iran and the challenges that we are facing in the energy sector. And then I will introduce a policy which is going to implement market for energy efficiency and environment, which we indicate as M3E, energy efficiency and environment. And I will present the case study result, which would be steel industry. And then I will conclude by co-benefit of energy efficiency and environment in this sector and the social and the energy sector of Iran. Energy use in Iran, very shortly, I should say that primary energy consumption is about 2.1 billion barrels of oil equivalent per year, and per capita energy consumption is about 26.8 billion barrels of oil equivalent per capita. As you can see, the per capita energy consumption is rather high when you compare the total economic development and the growth and the GDP in this country. And the GDP in this country is about $450 billion per year. And when you compare this amount of energy consumption and the GDP, that you will see we have a high energy intensity in our country. The greenhouse gas emissions related to energy sector was in 2018, it was 720 million tons of CO2 equivalent per year. And the total emission of greenhouse gases was about 810 million tons. And as you can see, the high percentage, or about 90% or 85 to 90% of these emissions is related to the energy sector. According to recent analysis, the potential of energy saving and emission reduction in of greenhouse gases is about 37%, which is equivalent to 800 million barrels of oil equivalent, and the reduction in the gas emissions, greenhouse gas emission is about 42%, which is equivalent to 300 million tons of CO2 equivalent per year, which is a rather high figure. And there exists a great potential for saving energy and also reducing the greenhouse gas emission through energy efficiency. This is a major point in our energy sector, and it shows the great potentials for saving and reducing the greenhouse gas emission, which is much higher than the NDAs or nationally determined policies or conditional policies that Iran promised in the Paris conference. The challenges that we have in the country is first, low energy prices. Electricity price is less than half a cent per kilowatt hour. Natural gas is less than 0.07 cents per cubic meter, and gasoline is about 10 cents per liter. When you compare these figures with the energy prices in the international market or energy prices in the energy market in many different countries, you will see that the prices are very low. And they are subsidized prices because the energy cost in Iran is very low. And the government has been able to keep these low energy prices for the final consumer. And it is a major barrier for any effort for energy efficiency. Another point that we have, which is a very difficult point and a major challenge, is increasing energy prices is usually faced with social unrest, and socially it is unacceptable. But in 2019, the government tried to increase the gasoline prices to about 15 cents per liter. Then there were about social unrest in the country. And the reason is that we have economic recession, and there's also a lot of corruption in the country, in the state institutions, and any increased energy prices is unacceptable by majority of the population who have a severe and difficult living conditions. And the third point, which is a major challenge in the country, we have a state monopoly of energy market. And this state monopoly has enabled the keeping energy prices low and continuing these subsidized energy prices, and also preventing any effort on energy efficiency. Although we have the many policies and laws which states that the energy efficiency should be increased or energy intensity should be reduced, but we have not been able to implement these policies. And I think the major issue is the state monopoly of energy market, which prevents any private sector involvement in the energy sector. And also the prices are administrative prices and they are determined by the government. And this oil revenue and the state monopoly has enabled the government to do that. Therefore, what happened, we need is structural changes in the country. How to do these structural changes based on considering these major challenges is that we have a price differential in the energy sector. For example, the price for households, as I mentioned, for natural gas is less than 0.7 cents per cubic meter, but it is about 10 cents per cubic meter for feedstock as petrochemical industry. And also we have export price differences. Therefore, any saved energy in the country can be exported if the private sector is allowed. Based on these price differentials and the current challenges that we have faced in the country, a policy has been formulated which is called Market for Energy Efficiency and Environment. The essence of this policy is that to utilize these price differentials and in order to promote energy efficiency without increasing the energy prices for final consumers in the social sector, which is a difficult matter when we consider the social and political issues. And the subject is that formulated in a way that if one saves energy in heavily subsidized sector, then saved energy can be sold or traded or can be exported. And this regulation was approved in 2017 by Supreme National Energy Council, and it allows for investors or energy companies to do projects and save energy and to sell the saved energy in other sectors who have high prices or to export it. Therefore, with this sort of policy, what we did actually, we tried to overcome the challenges of social unrest and social unacceptability of increasing energy prices. Therefore, we have been avoiding to increase the energy prices for final consumers, especially in the social sector, that is households and transportation, in order to have to overcome this challenge. But at the same time, we are creating a shadow market, or I should say that it is another market, which is called energy efficiency market, which gives some incentive for investors to invest on energy efficiency. And it will make some of the projects very feasible in different sectors, especially in the sectors where the energy subsidy is the highest. Let me introduce an example when this policy implemented, what will happen. Energy consumption in Iranian steel industry is about 24 gigajoule per ton of steel. If we try to optimize based on the design cases of this steel industry, it is possible to reduce this 24 gigajoule to 16 gigajoule per ton. And the actual emission of greenhouse gases equivalent to CO2 is about 1.7 tons. It would be possible to reduce it to 1.3 through improving the energy efficiency. One of the major sectors of the steel industry is iron reduction, where the huge amount of energy is lost here when the gases with the temperature of 450 degrees are cooled down with water to a great extent to ambient temperature, and then energy is lost here. And also we have here stacks where a huge amount of energy is lost, and at the moment the temperature of exhaust gases here is about 400 degrees Celsius, but you can see there are tremendous amount of energy losses in these areas. And also the one other problem is that the synthesis gas, which is introduced for iron reduction in this plant, also is values, and it will be possible to control it through developing optimization models and introducing an application of these models. It will be reduce the flow of synthetic gases to optimal level. All these measures can lead to reduction in energy consumption. And since the natural gas is used as a reforming here for producing synthesis gas and also heating and providing the required heat, therefore it will lead, this energy efficiency will lead to reducing any natural gas consumption, as will lead to reduction in greenhouse gas emissions. Well, what would happen if we reduce these greenhouse gas emissions? If we consider the international prices for natural gas at the Persian Gulf, which is about 15 cents per cubic meter, the cost reduction of sponge iron would be about 42 euros per ton. And carbon trading, if we are able to carbon trade this, reducing in greenhouse gas emissions, it would be possible to receive 4 euros per ton at present prices in the international market. Therefore, economic potential of these production of and introducing energy efficiency in total in steel industries in Iran would lead to saving of 1.2 billion euros per year. You can see where it is a considerable amount and is a huge amount of economic potential that can be realized in the steel industry through introducing energy efficiency. And you can see here the interlinkage between economic, environment, and also this energy efficiency. And there is a co-benefit in the energy efficiency and environment and economic in this sector, you can see very easily. The long-term approach would be to replace the whole lease plan, which comprises about 60% of total investment for iron reduction plant, with a new technology which is producing hydrogen and using hydrogen as reduction element in the steel steel plant, in the furnaces. If we use hydrogen, green hydrogen especially, for reducing the iron in this furnace, what will happen? Then we will see that this is the price per ton, cost per ton of sponge iron at the present plant. And if we produce hydrogen through solar energy and use hydrogen for reduction, it will be possible to reduce this cost to 125 euros per ton in Iran. In this scenario, I have considered the cost of natural gas 15 cents per cubic meter, and the hydrogen cost for Iran, considering the 60 kilowatt hour per kilogram of hydrogen, which we needed, and we use solar energy, and considering the low temperature steam plus power for hydrogen production, which will reduce the electricity consumption for hydrogen to this level, the cost of hydrogen will be reduced to 2.5 euro per kilogram. You can see the hydrogen cost, green hydrogen cost in Iran is comparable as in competitive with the prices of hydrogen in the world, in Europe or United States, which are in Europe, especially in Netherlands, you can see that it's the cheapest. It's about 3 to 4 euros per kilogram is traded in the spot market. And the cost here, the production cost of hydrogen, green hydrogen, is much cheaper. And therefore, if we introduce this technology as a medium term, not only we will eliminate the production of greenhouse gases, and also the cost of producing sponge iron will be reduced by about 3 euros per ton compared to the present situation that we have in the country. And you can see that there is a great interlinkage and the considerable interlinkage between economy, energy efficiency, and environment in this case, which provides a lot of opportunities for Iranian economy and also energy sector in Iran to utilize this interlinkage for accelerating the sustainable development in the country. Opportunities that exist for using hydrogen in steel industry, that we have a DIR technology which uses synthesis gas for reduction in steel industry. Therefore, it will be very possible to introduce hydrogen to this technology in many steps. In the first step, one can add hydrogen, green hydrogen, to synthesis gas by about 5%, 10% at initial stages. Then one can increase it gradually to about 40%, and it will help us to learn a tremendous amount of technological issues by introducing hydrogen. Finally, it will be possible to use 100% hydrogen for direct production in steel industry. We have considerable sources of energy, solar energy, which is huge amount of solar energy and is more than fossil fuel resources in the country. And the plant factor, capacity factor for solar energy in Iran is very high compared to other countries. And therefore it makes the production of hydrogen by solar energy very cheap and competitive with other sources. And therefore we have also access to technology very easily, can be accessed. And I don't see much problem in this case. The only problem is that the challenges that we have, the energy sectors, and if we introduce the energy efficiency market and environment implemented in cooperation with other countries, I'm sure it will be helpful and it will lead to rapid structural changes in the Iranian energy sector, which is usually hindered by the political sanctions that we have at the moment. Policy requirement for energy sector in Iran is speed up of implementation of M3E. Actually, the problem that we have had with political sanctions that was introduced against Iran has accelerated this problem, and the government has reached the conclusion that we have to try to find ways and means of this realizing the potentials that we have inside the economy. And one of the main potentials is the energy efficiency in this country. And to introduce the structural changes in the energy market, it means that promoting private sector for investment and reducing the government involvement in energy issues, and trying to raise the position of the government to governance, a good governance, rather than involving in the energy production or trying to energy supply system. And therefore, introducing the private sector and supporting the private sector for investment in energy sector, not only Iranian private sector, but international private sectors also, is one of the objectives that is being heavily followed in the Iranian economy and at high decision makers. Utilization of the cooperatives of energy efficiency and environment that I pointed out, the iron stone industry is one of the cases and examples, and we can find many examples in the country where we can use these co-benefits of energy efficiency and environment, not only producing the many energy intensive products using the renewable energies, but also producing LNG, which can be considered as the main source fossil energy that will be probably used in the medium term until 2050 or 60. And Iran can play a very good position, can be a good player in this case if we promote the private sector and use energy efficiency, like using turbo expanders and other means of CHPs in the gas network, and producing LNG, where the cost of producing LNG will be reduced dramatically because we are using energy efficiency, and it will lead to cheaper LNG and competitive LNG in the country. Therefore, there are many potentials in the country. By using or realizing the potentials of energy, it will be possible to make energy sector competitive in the international market, and also to promote the private sector for further investment in this sector. I thank you very much for this opportunity that you provided to me. I thank you especially Professor Houman Farzaneh for providing me this opportunity. It has been a great pleasure to be in this workshop. I will be at your disposal for any questions or further comments that you may have.
Okay, thank you so much, Dr. Sabuhi. I really appreciate you coming to us from Iran to deliver this presentation. And I think you highlighted some really important opportunities, especially among iron and steel heavy industry, and how hydrogen can open up some potential to deliver co-benefits in both of these industries. I think the other thing that came through from your presentation is that, in order to make this co-benefits approach work, we not only need sort of some innovative and breakthrough type of technologies, but we need broader changes to the policy environment. So you talked a little bit about structural changes for energy, and I think that sometimes these broader structural changes are just as important as the quantification of the co-benefits. So I really liked your presentation that you highlighted both of these points, and I think it's a theme that will come up throughout our discussions today. So thank you again, Dr. Sabuhi, it's great. So then let's, now I'd like to move the presentation over to my colleague, Dr. Houman Faraze. Dr. Houman is a professor at Kyushu University, where he focuses on quantitative and qualitative analysis of different energy problems. And he's done an incredible amount of work on measuring and quantifying co-benefits and developed tools to be used towards these ends. He's currently working on a tool with I²CNER that will help quantify co-benefits from heat-only boilers and solar energy in Mongolia. And he's also worked on a tool for quantifying co-benefits from wastewater management in Indonesia's fish processing industry. So with that introduction, Professor Houman, the floor is yours.
Okay, thank you very much, Eric, and thank you very much, Professor Sabuhi, for the very nice presentation. Okay, so the title of my today's presentation, as Eric mentioned, is about the multiple benefit assessment of the utilization of high efficiency heat-only boilers in Ulaanbaatar in Mongolia, which is basically a joint project between Kyushu University and I²CNER. And I'm serving as the principal investigator of this project, collaborating with Dr. Zusman and his colleague at I²CNER. So I just want to brief you about this project, the main content and some achievements. So the details of calculation and the modeling approach is available in the book that Eric mentioned, chapter 4. And I would like to invite you, please refer to the book to get more detailed information about the calculation process. So, so the topic, as I mentioned, is about the Ulaanbaatar, which is the capital of Mongolia. And this city is ranked among 5, polluted city in the world because of the PM and particulate material, which is the main problem in this city. And so, as you can see here, the I show the pointer. As you can see in this figure, sometimes, especially during the winter time, the peak of PM 2.5 reaches to even more than 3,000 per cubic meter, and the average is much higher than the standard level of the WHO. So the main reason is this area, as you can see in this traditional Ger area in Mongolia, and the main purpose of this heating system in this area is to provide space heating and hot water, and so the main source of heating is coal. And in addition, the people in this area, they use very low efficiency stoves, open stoves, and heat-only boiler for space heating, which the efficiency is very low, and also the emission of the particle material is really high. So that's the big issue and concern in this area. So based on that, in alignment with the Japan-Mongolia partnership, and based on I²CNER project and under the Ministry of Environment, Japan, there was a project to how to actually replace these low efficiency heat-only boilers with some high efficiency one provided by the Japanese company. And then, so you can see one of these sample, which is located in Ulum Som. This is the central department of Mongolia, and this is the main heat-only boiler. And the idea is how to remove and how to replace this kind of HOB systems with the new one. And the new one includes several areas for improving the energy efficiency, like the protecting the the coal storage, and then preheating the inlet air, adding the advanced system for cold feeding and air and fuel adjustment system, and also the adding the cyclone separator for eliminating and separating particle material. So this is the idea, and this is the practical, actually, the pilot, which is proposed by MOEJ. And then this system have been installed in several places in Ulaanbaatar, and we've been asked from Kyushu University, because our research basically focused on multiple benefit assessment and quantification and quantitative analysis of climate co-benefits. So I just actually asked us to join this team to make some tools, basically toolkits, to be used for quantification of these co-benefits after the implementation of new heat-only boilers. So this is the story of this project. And so the co-benefits that we are focusing on in this project on here are reduction in local air pollution. We also try to address the improving the public health and also local economy in this project. Okay, so what we have done within last 3 years, the project has been started since 2018. We try to make a bottom-up technology assessment spreadsheet tool, which is developed in Excel. So the interface is very simple, and we try to simplify the calculation, but the calculation process behind this tool is too complicated. So the idea is that this tool can be used by the stakeholders, not the only academia. So that's why we try to make some interactive interface and simple interface. What we can do with this tool, basically, the first step is to quantify the environmental co-benefit, including greenhouse gases and other local pollutants, mainly the particle materials. And in addition, we try to quantify health and economic benefits. So the main parameter, technical parameter in calculation or in estimation of the co-benefit, especially the air pollutant, the amount of air pollutant for the heat-only boiler, is the thermal efficiency. And what we have done here, based on the the standard of American Society of Mechanical Engineering, SME, we try to use the indirect method, and we try to quantify different heat losses from excess loss to, for example, surface radiation, incomplete combustion, all the different heat losses within the heating process in heat-only boiler. And then based on precise estimation of thermal energy efficiency, then we will be able to estimate the amount of coal, and based on that we can calculate the the amount of the carbon dioxide emission and other pollutant using the local and international emission factors. So this is the calculation process based on the definition of two scenarios: baseline scenario and intervention scenarios. The intervention scenarios are those that I showed you, the different improvement areas. And then the data includes the coal types, like the ambient condition and boiler technical specification, and some details about type of coal, calorific value, and also emission factors. And the process shows here how to estimate the thermal efficiency, and then the amount of coal, and the next step to calculate the carbon dioxide, GHG, and other air pollutant. So co-benefit can be estimated based on the difference between baseline and intervention scenario. So furthermore, we try to focus on health benefit assessment. You know that the very important term in health benefit assessment is DALYs, which is sum of the years of life lost due to premature mortality and morbidity. This is the standard definition, which is basically introduced by WHO. And then we try to focus on this definition, and then try to make linkage between the concentration, like the different pollutant, and different health endpoints, like different diseases. So for that, we need to use the exposure and concentration response function, and then collecting data about the mortality rate in Ulaanbaatar, and also the annual dailies attributable to PM in the city. So this data basically collected from a local database, and some of them from WHO. And then we try to estimate the population attributable risk function, PAF, and based on that, we try to estimate the amount of dailies which can be averted during the implementation of new scenarios. Let me share with you the case study that we studied in this project. So this is about one of the heat-only boiler which is installed in school number 65 in Ulaanbaatar. And here you can see the current situation, which is really bad, with a huge amount of excess air and a very, conventional cold feeding system by hand. And then after the implementation of new scenarios suggested by MOEJ, using different technology like vibrating stokers, improving the air efficiency, and also, reducing the particle material by adding the cyclone system, so we can get better condition with higher efficiency. And when we try to simulate and estimate the amount of the co-benefit by this tool that I explained to you, we calculated the amount of pollutant in different scenarios, like when you try to add cold storage or a cyclone or air preheater. So you can see the potential reduction of different pollutant and the GHG for each scenario, and then the combined scenario, which brings the more than 300 ton per hour of carbon dioxide reduction for only replacing one HOP. And this is how to visualize the co-benefit here. Here, the co-benefit in terms of the environmental assessment is basically the different air pollutant. So you can see the linkage between the reduction in GHG emission and other air pollutant, like sulfur oxide or particle material or carbon monoxide and NOx. Then you can see how these two terms are connected by in different scenarios. And in the left side, you can see the effectiveness of co-benefit project in terms of different scenarios. For example, the best scenario is cold feeder because it includes the air adjustment and also the better system for cold feeding. So this kind of thing is really important, especially for the local stakeholders. We need to visualize. We need to visualize the result and show the impact of co-benefit. The main idea from showing this to stakeholders is, when we discuss about the climate change and environmental project, it needs a lot of money. It's very cost intensive. So we want to say that by calculating and quantifying this co-benefit, you can get some benefits, even in terms of money. Then you can offset the cost, the initial cost of the project. So this is the main idea behind the visualization of co-benefit. And so here you can see the result for public health assessment. Then we discussed different exposure groups like adults and children, and different diseases like the pulmonary diseases like the respiratory diseases, lung cancer, and TB. So we collected all of this data in a very comprehensive database behind this tool, and then the user can assess the impact of the new technology in terms of PM emission reduction and also daily averted, which is really important. So this graph shows when you put all co-benefits together, then you can get this graph which shows the main idea of this research, that here this part shows the amount of potential reduction in GHG, and this is when you monetize the impact of health benefit in terms of cumulative GDP that you can achieve by reducing the admission cost of hospital and other diseases. And you can see here by deploying one high efficiency heat-only boiler in Ulaanbaatar, about 64 years of healthy life in Ulaanbaatar can be provided. This kind of result is very interesting. So we try to scale up this result and try to apply our model to all available HOBs in Ulaanbaatar for 250 HOBs until 2030. And these are the result in terms of the reduction of GHG emission, reduction in PM, daily average is about 16,000, and saving in terms of money is about $44 million. And even we try to consider the reduction in unemployment rate and other local economy indicators. So this is the generally, overall, explanation about the research that we've done in collaboration with I²CNER so far. And this year we have some training workshop for this tool with the stakeholders. And hopefully we want to work on the next step of this tool. So far, next year, we focus on technical dimension of co-benefit, like that I explained to you. But there is another dimension, which is the institutional dimension, which includes the governance, legal, capacity, regularity framework. These are also really important. The question here is how to assess the total co-benefit as a product of these two dimensions, technical dimensions and institutional dimension. This is the future, step of this project. So I invite you to read the chapter 4, which we explain the details of this calculation with the same title in this book. Hopefully would be available online by the end of the March this year. And I hope you can enjoy reading the different chapters in this book. So thank you very much for your attention. And if there is any question, I would be very happy to answer.
Okay, thank you so much, Dr. Human, for a very interesting presentation on the heat-only boiler. And what I think I'd like to do now is we're initially going to have a break, but I think we're going okay for the time being. So let's have the next keynote speech, and then we'll have a break after that, and go into the next session. So for our keynote speech, coming to us from Vienna, Austria, and the Institute for Applied Systems Analysis, we have Bldg Kleinmont. Bldg is a research scholar at I²CNER, and he works there on assessment of regional and global emissions of various air pollutants. He leads the development of models to estimate emissions and mitigation costs of ammonia, non-methane, volatile organic compounds, and particulate matter, including black carbon. And many of these models and the integrated assessment framework, which is part of GAINS, have been supporting development of air pollution policy in Europe, in particular under the Convention of Long-Range Transport and Air Pollution. And Bldg is typically presented to us here in Japan, but given the COVID crisis and the limitations on travel, I think you can see him in his office in Austria. So Bldg, I'd like to turn the floor over to you, and really glad that you're actually going to be presenting on some of these urban and rural linkages as part of a project that the MOEJ is supporting. So the floor is yours, Bldg.
Thank you very much. Thank you very much. Good morning. Good morning for me. Good afternoon for you in Japan. Thank you very much for giving me the opportunity. Eric, I want to ask you, do you see my full screen? Because I'm always confused with two screens.
Yeah, so right now what we're seeing, Bldg, is you have it on display mode, I think, so we can see not only your current slide, but also, there you go.
So this is better, okay, because I'm sorry, I'm having two screens and this is always a little bit confusing, to me at least, on my side. Thank you very much. So thank you for the opportunity to deliver this speech, and this is not a very typical maybe keynote speech that would this would mix a little bit more general statements and conclusions from different work with examples of also ongoing work and looking into next year or this year and next year work that would deliver further insights at the level, both at the local level as well as at the larger scale level. While my title is referring specifically to urban and rural air pollution in Asia, but I will have both, actually two parts, and examples from local level as well as large scale, regional and even global air pollution and policies that are needed to achieve ambitious targets to reduce air pollution. And apologies from Markus Amann, who is not able to join us today. And traditionally, we've been very often participating jointly in these meetings and delivering talks. But best regards from Markus. So let me start with something that all of you are familiar with, but just to put us on the same page and remind us about some of the key questions when we talk about local and regional air pollution. Policymakers, scientists, we ask ourselves a question: what are the key? We need to understand key emission sources. And the next question is, what do we do about it? What would be the cost-effective way of reducing pollution exposure? And in recent times, we mostly talk about particulate matter, although we should not forget about ozone. And Eric has mentioned in his introductory presentation about co-benefits, black carbon and tropospheric ozone. And this is a good example that cuts across two areas of health exposure and also connecting nicely to the near-term and longer-term climate change. Now, in terms of key challenges, and I focus now on PM2.5, PM2.5 fine particulate matter resides in the atmosphere from days to weeks and therefore is being transported over long distances. And we have to realize that whatever we measure as ambient air in terms of PM2.5 has a fairly long history, meaning that it not only comes from local sources, which would be typically attributed to primary PM2.5, but also from longer distance, could be, as I said earlier, hundreds of kilometers. And these are secondary particles that are formed from precursor emissions of sulfur dioxide, NOx, ammonia, and VOC. This is very important because effective control across these pollutants and various sources are needed to effectively deliver reduction in concentrations and exposure. And I will try to show that on examples of modeling that we have done and at the local scale as well as at the regional scale. An important thing, of course, and it's in fact not only true in Asia, it's only that some of my slides focus on Asia, is that effective control includes this several options, and some of them are not very well understood and could be overlooked, both in terms of understanding their emissions, spatial distribution, as well as mitigation opportunities and costs of the mitigation. And of course, we should not forget the local factors that will have strong influence on the analysis and the results. And of course, this includes meteorological factor and natural sources of particulate matter, as well as the issue related to availability and knowledge, experience in local technologies and institutions that are responsible for both introduction of the new laws, policies, as well as enforcement. The level of enforcement is one of very important elements in successfully delivering reductions. Let me show first and go back to the regional scale before I move to some of the examples for local and urban scale. Many of you would know, and many of you participated in the science-based solution UNEP CCC study that looked into Asia and reviewed situation in terms of pollution, as well as offered opportunities, analyzed opportunities to mitigate air pollution. What I show here is just selected example for East Asia from that study, where we have calculated for 2015. The map shows concentration of PM2.5, And this is the population weighted exposure. It's about 50 micrograms here or 45 micrograms in 2015. Current policies, and this is the important thing is where I mentioned enforcement on the previous slide, is this blue part in here. So this is looking into 2030 and using baseline scenario that we implemented at that time. This is assuming that policies that are implemented before 2015, as well as in the current legislation that was prescribed by 2015, that would deliver very important benefits of reducing PM2.5. So here the enforcement component is extremely important. It would bring some reductions, although you see these red bars in here, they indicate actually the national standard in many countries. And then that's about 35 micrograms. And then the WHO air quality guideline, which is 10 micrograms, which is difficult to achieve. Now, in the next step here, the further policies that were analyzed and described in detail in this report, I'll come back to that in a minute, offer a big opportunity to reduce emissions further. And as you see on the map here showing concentrations, this is getting much closer to going out of the red and yellow area into blue area, which shows everything below the national standards. And some of the areas here, this is dominated by natural sources. So this study has shown a number of measures that allow to mitigate emissions. And again, the blue color indicates the current legislation and current commitments that would deliver both in terms of greenhouse gases, as well as, because this included already NDCs, as well as reduction of air pollutants and primary particulate matter, but also, of course, SO2 and NOx that is not explicitly shown in terms of mitigation. We are just showing here black carbon as one of the climate forces, and would deliver on SDG benefits related to health. Certainly, of course, climate change as well, but this is a baseline, so I have not highlighted that specifically. The opportunities that are shown here, you see this yellow bar, this is compatible with what I've shown in the previous slide as this opportunities going beyond current policies that still require a big effort to effectively be delivered. There is a number of opportunities going beyond that, and they would include conventional controls. This is something that is well understood and it's done in many of the countries. Examples would include implementation of effective implementation of controls on big industries and power plants, follow-up of transport policies. The next stage measures would include areas like agriculture, burning, and also agriculture. So you see here, what I mean here is manure and fertilizer use. So this is something that is often outside of the scope of the typical air pollution policies, and that would deliver also significant benefits for methane as well as air pollution, because agriculture plays also an important role. And therefore, improving nitrogen efficiency is very important, and reducing emissions of ammonia is very important. And finally, development priority measures, just to mention one example, is of course cooking and stretching ourselves to deliver clean energy to all is very important part of that strategy, but also further measures that often are perceived and are pursued also as climate measures could be here motivated by the air quality policy that would include energy efficiency improvements and further renewable energy. Now, I picked up one example from this study, and you see here again the same colors are used. Current policies, this is across all Asia, current policies are indicated by blue, and they achieve population weighted here exposure. This is very large scale, very difficult to downscale here from this chart to local conditions, but this is to indicate the total potential distributed across a variety of measures that I mentioned already before. But what I want to highlight here is that this measure cut across many of the areas that are these cross-policy areas that were mentioned by previous speakers. And so I highlight here a couple of examples that would include energy efficiency improvements in renewable energy, coal mining, oil and gas, brick kilns, energy efficiency standards in households, road vehicles, energy standards, renewable for power and generation. You see that many of them deliver also further potential. There are existing policies already when we look into road vehicles, for example, but there are still in some countries a potential to deliver on that front. These policies will bring both climate and air quality benefits. The other examples would include, for example, electric cars, improved public transportation that don't deliver here specifically very much of additional benefits, but of course, this is one path towards improving air quality. One could imagine that we would accelerate policies in road vehicles, and some of that is achieved here through better standards could be actually achieved by much faster electrification. So the potential should not be neglected. And of course, at the local level, the picture might look differently. The next one is sustainable agriculture that I mentioned. You see here the important contributions from an area that is often forgotten or at least not included as part of the air quality policy. Livestock manure management, agriculture and crop residues, and actually this is something that there's a lot of discussion about, and reducing open burning and banning effectively open burning of residues. But then nitrogen fertilizer application, urea is one of the fertilizers widely used that is producing significant emissions of ammonia in many different regions. That offers a large potential cutting across agriculture, sustainable agriculture, and delivering both on the air pollution through reduction of ammonia, on climate because of simultaneous reduction of methane. At the same time, this has also these kind of measures contribute also to other dimensions, including soil and water pollution. And finally, there's a couple of measures mentioned here, like waste management and landfill gas. Again, cutting across air pollution, delivering here on the scale of reducing exposure, like, for example, reducing open trash burning, and then solid waste management that is connecting to climate policy also, reducing methane emissions. Going even to larger scale, let me show you two slides and examples of a global perspective from a recent paper that was published just at the end of 2020, where we looked into a target of WHO air quality guideline of 10 micrograms, and we found at the global level there's a lot of detail given in the paper, so I will just go at a very, very high level in here. If we look into population, billion people that are exposed to levels below 10 micrograms in a very ambitious scenario that we call clean air scenario, none of the single policies that are indicated specifically down from here could do enough, even if ambitiously enforced. About 2/3 of the policies beyond current legislation, this is the existing policies already, about 2/3 would be associated with the typical air quality policies, while another third would require measures in agriculture, food policies, so food consumption, as well as energy and climate policy measures that are often associated with climate policy. So this is turning it a little bit upside down and trying to look into the drivers that would be needed to control air quality. But of course, there is strong interaction with the climate policy. That's a very busy slide. Let me very quickly highlight the connections here between many, many different dimensions. On the left side here, in the middle actually, you see here impact of reducing population-weighted exposure from 2015 to 2040. And again, current policies, these are reductions of different pollutants. So these are air pollutants. We look into direct health benefits. This policy would deliver direct health benefits, particularly in urban areas, addressing various SDGs. And these are the blue is showing very large potential in Asia for this various policies, reducing pollutants significantly, and then connecting also to greenhouse gases and short-lived forces. So the right side shows reductions that are associated with these policies for black carbon, organic carbon, CO, and greenhouse gases, CO2 and methane, that are available here as part of these opportunities, addressing a number of other SDGs, so extending actually this whole area into a multi-benefit area. Further, something that I mentioned already before, agriculture. There is no way to actually get that low and achieve this mitigation here shown as ammonia, for example, mitigation. That's not easy to control. You see reduction potential is a bit lower. And there's not much done at a global scale yet. That would address a number of SDGs that is a very important part of this future policy. Many of these policies actually are no regret policy measures addressing air quality and climate nexus. This is what I tried to highlight on the previous slide, and these are just examples here that I'm not going to read through all of them. Energy efficiency improvements that cuts across many different sectors. Promote electric cars and shift to public transport might be much more important locally. Sustainable agriculture. This is an important component that cuts across many domains, as I said, air pollution through ammonia and reduction of for climate because of methane mitigation. And waste management that has many dimensions. And in here, what I highlight are specifically those that address both air quality and climate nexus. So recovery and use of landfill gas, improving overall waste management. An important component in all of that when designing policy, of course, is consideration of rapid implementation or multiple benefits that are considered. So institutions are very important to assure that this is possible. There's a lot of experience in some regions, so depending on part of the world, this can be effectively used. Let me move to a project that has started in 2020 and is looking into the interactions between urban and rural air pollution in Asia. And this is something I actually addressed also last year at this meeting that was, I still managed to travel at that time in December to Japan. Air pollution in Asia, perceived often as urban issue, is often addressed also at that level. But as I mentioned already before, the contribution to this pollution is originating, a lot of that originates outside of the cities, and policies have to cut across. The objective of this study is to reveal some of the interdependencies between observed urban pollution and mitigation opportunities within the cities, as well as outside of the cities, and highlight different elements and both benefits in terms of health benefits, but also economic benefits, and those that cut across many of the SDGs. The expected results would look into building something that some of you have seen. This was published in Atmospheric Environment, the study for Delhi that has shown that the pollution in Delhi is originating, of course, within the local domain, but more than half is coming from neighboring regions. And policy has to address many different sectors. And addressing that at a larger scale will have also cost savings because depending on the pace of introduction and cutting across different sectors, at the same time, and efficiently, policies can deliver significant reduction to pollution, and will address co-benefits that will cut across air pollution and also climate. This is a large agenda that we have for this study, but that is in progress and requires a lot of analysis and modeling that we are actually doing currently, and I would like to show you a couple of benefits. This is a long list of benefits that will be explored. I tried to make in bold few key elements here. Compliance with air quality standards, especially focusing on urban and rural areas. Number of households using solid fuels and how it will change it can change with existing policies or proposed new policies. Change in population exposure in each of the country and also in some of the cities and larger conurbations. Life expectancy for ambient household and air pollution and ambient air pollution, including analysis of gender, and emissions of greenhouse gases, short-lived forces, so addressing near-term climate and climate impact indicators, various climate indicators. The list actually is quite long and very ambitious. I'm not sure we will be able to address all of them, but that's the target is to see to what extent we could address some of the other benefits. I mentioned actually agriculture. So that's something that we certainly will be doing and trying to assess the impacts of these policies addressing, in principle, urban pollution, but through both local and regional measures, address also agriculture and the benefits on other SDGs. Now, the study in Delhi actually has shown that this effective reduction of policy at the local level is not enough to look within Delhi, but to reduce really pollution, we have to collaborate. There's a need to collaborate with neighboring states. And that the effective policy interventions have to go across many of the sectors, and some of them are not very typical in industrialized countries. Something that we have a lot of experience with is really high stack and diesel, but even agriculture more recently, but a lot of these sectors actually are not well understood, and there is a collaboration needed and joint work. And of course, as mentioned already before, many of these interventions moving from here actually through local and regional measures jointly will cut across many SDGs and bring reductions of greenhouse gases as well as air pollutants. What we are doing is, and this is the current work is progressing on both South and East Asia, is analyzing impact of different emissions of different sectors on concentrations. So what you see here is impact of measures in only one sector, and this is power generation, large industries, brick kilns, mobile sources, how different patterns are. This is quite obvious, but it's needed for the analysis so that we can effectively find then measures that will affect differently concentrations at different locations. Note that this is a log scale, so it highlights here some of this area stronger, and you see also some of the lower contributions in sectors like residential, commercial, open burning of municipal waste, open burning of agricultural residues, as well as nitrogen measures. And you see here on this example for South Asia, how differently some of these measures will, how different benefits actually, or how differently spatially distributed benefits it will bring. Now, one slide on the progress of work. These are cities actually in India, showing in Indo-Gangetic Plain that similar picture like for Delhi shown in this paper that was already published emerges from many other cities. The dark red shows here the local city contribution to PM2.5 concentrations, and this lighter color here shows from the same states of cities within the same state. Sometimes these are relatively large regions, but the important is that this is different jurisdiction. So these are areas that one have to talk and work jointly between the two jurisdictions to achieve this kind of reductions. And this is going across policies or regions across all country. So that requires even further coordination. And this is not WHO quality guideline. Actually, this is WHO first stage guideline. This is consistent with the national standard. So it's 35 micrograms. So a very similar picture emerges showing that this collaborative effort cutting across many sectors is necessary. Let me give you an example before concluding for Vietnam that we have been doing jointly with the Academies of Sciences, Vietnamese Academies of Sciences. And this is looking into northern Vietnam. And this is 2015 assessment of air pollution, a widespread exceedance of national standards. All that is not blue is above 25 micrograms PM2.5, which is the national standard. And that means that about 70% of population living in this area is exposed to PM2.5 levels above the national standard. And especially Hanoi, as we see in here, is actually all well above the standard. And in terms of source apportionment, this is again a very similar chart like for India, and like shown for Delhi. The major part of pollution comes actually from outside of Hanoi city. So city of Hanoi alone cannot solve that problem. And we looked into this work at the evolution towards 2030. You see concentrations are actually increasing, both at the regional level, there's an increase in contributions from power sector, for example, as well as local pollution. To address that, we focused on measures only in this province, so only addressing reduction in Hanoi. As you see, it does not bring very significant reduction. It does bring reduction, but not very significant. More significant reductions are achieved when both regional sources, and you see here the reduction are addressed along with Hanoi. So very similar picture like it was shown for Delhi or some of the other cities. Now, to finish off, something more exploratory, a little bit busy slide, but we are doing this kind of analysis for all of the major cities. And here an example of Karachi, and the same type of waterfall chart, as we call it, showing city contribution and immediate neighborhoods, different distribution of this pollution. This is residential sources, this is mobile sources and waste. And now what we look at is cost-effective mitigation. So we are looking into analysis of reduction from this area, building this kind of cost curve. Now that looks like a very, very busy picture, and it is a very busy picture. I want to highlight one innovative element in this analysis, and this is becoming slowly a standard output of the model that we are operating, that with what we are calculating or showing here reduction in PM2 concentrations. And on this scale, we are showing marginal cost, could be shown also as total cost of cutting microgram of pollution. So the measures are ordered. This is looking very flat here. Could be, of course, shown differently and highlight just the cheaper measures that say fall below 50 million euros per microgram. But what is visible here is that there's a lot of measures in industry that are cheap, improving efficiency of mitigation of dust pretty much is showing very effective, and LPG stoves, and of course off-road transportation, that is quite an important, road and off-road transportation, that is an important part of the mitigation. So we will be building and further analyzing that and trying to present it in a bit more friendly way also at different scales to show that cost efficiency. Let me finish with few concluding remarks highlighting what I tried to say during this presentation. We need an integrated approach cutting across different, both regions, scales, as well as sectors. We need to consider a wide range of emission sources addressing both urban, rural, and regional pollution. Coordination between cities and neighboring regions is especially important with regions with high concentrations that are far from the air quality guideline. At the larger and regional scale, the multiple policy domains need to be addressed. Energy efficiency, climate, air pollution, agriculture, waste management, food consumption patterns. And this will bring a number of benefits and multiple benefits cutting across different SDGs. Many of these policies actually are no-regret policies addressing both air quality and climate nexus. One statement I would like to highlight that is important from our perspective, the way we see this: better understanding of multiple benefits of policy interventions and their distribution across different groups in the society could enhance public support for changes that are required for the long-term transformations. We certainly need long-term transformations. Climate change is on the agenda of all of us. Communication of the needs and communication of measures that need to be pursued to achieve these long-term transformations and effectively reduction of climate change is very challenging, has been very challenging over decades. And one vehicle that could help us could be to address these near-term policies that cut across and deliver locally for different society groups. Policymakers could benefit from that because they could demonstrate their success and would put us on the path that is consistent with this long-term transformations. The final statement is our model. I didn't want to spend time talking about it, but that's GAINS, that is actually suited and further built to explore exactly the statements highlighted here in bold and explore also these multiple benefits at different scales. And collaboration with local partners, which we are pursuing within this I²CNER MOEJ project, is absolutely essential. Thank you very much, and apologies for dragging for a few minutes longer. Thank you very much.
Hey, thank you so much, Zig, for this very enriching and illustrative presentation. I mean, I think you did a very nice job of highlighting some of the key findings from the solutions report and then demonstrating how those are being taken forward under the context of this MOEJ project. Some of the key messages that came out for me are that this urban-rural linkage is absolutely essential to mitigating the PM 2.5. And that we need to look at not just air pollution and climate benefits, but the distribution of those benefits to different segments of society to help build public and I would suggest also political support for some of these interventions. And I think your presentation also jives nicely with the presentations previously from Dr. Human and Dr. Saluhi in terms of emphasis on energy efficiency as a low cost and relatively effective measure for reducing PM 2.5, as well as some of the institutional changes and policy changes that need to capitalize on that potential. So thank you so much. I know we're running a little bit over, but I'd like to see before we're going to take a quick break after Zig's presentation, but I'd like to see, does anybody have any questions for Zig? You can either raise your hand or speak out, whatever's easiest for you. So Zig, I'd like to ask you one question while we have you on the line. And just this regards the finding on the linkages between the rural and the urban air pollution. I mean, you mentioned that it's important for us to think about how these neighboring areas collaborate with cities. Have you seen any examples of, in any of your research, of cities and neighboring areas working together well? And if so, what is promoting or providing an opportunity for that type of collaboration?
That's a very good question, because this is always a challenge. How do we measure also our success? How are we managing to deliver some of these messages successfully? We've been working a few years already in this area and have been also supported by the World Bank in some of that. So that's a very good question. We've seen, honestly, through the first years, much more problems in this collaboration, and initially quite a lot of blame, or using first for an opportunity to use also this analysis to show how important contribution from the others and pointing to the others is, rather than immediately sit around the table and think in terms of solutions. This is quite difficult, I think, to achieve, but it has been happening. We've seen that in the discussions in Hanoi, for example, that the local EPA or local EPAs of the 3 neighboring regions have been actually talking much more together. That has been recently also supported by the analysis that the Finnish Meteorological Institute has done on source apportionment studies. I think what I did not manage to highlight in the presentation is the fact that this kind of modeling analysis and discussion also of policies has to be connected to more work on understanding and validation of the tools we are using. And this has been successfully done now in Vietnam, in Hanoi, where the measurements for the full year have been completed at few stations in Hanoi that are actually providing additional evidence for pollution originating from outside of the city. And this has triggered a substantive discussion on how policies can be shaped that jointly to stimulate this kind of policy. The other example is that after many years working in India and demonstrating some of the pollution coming, or how pollution should be pollution management should be taking place to actually reduce successfully emissions in Delhi, is there are 2 events. I think one is COVID also, because COVID has shown in many of these regions that suddenly clean sky was seen in cities that they haven't seen for decades, actually blue sky. And everybody knew that apart from there has been local lockdowns in a way where traffic was stopped or strongly limited or power plants, not power plants, but maybe industries were stopped even. And this had very limited impact on local pollution, but while COVID, a wider cut on regions around, actually had quite immediate results on air pollution and air quality. And finally, an example that recently India has been pursuing actually new policies and legislation based on this work and stimulated by joint work at the regional level. There are new policies coming in initiatives that are coming from within Indian governments across regions in the northern Indo-Gangetic plain to jointly look for solutions in a collaborative effort.
Thank you so much, Zig. I think one of the points you're making here that's quite interesting is that by developing a sort of stronger evidence base for decision making, that very process of bringing in the different stakeholders to sort of co-design and co-develop this evidence also helps to facilitate some of the coordination that will be needed to actually implement its results. And YASA is with their reputation for doing high quality research, but also as sort of an honest broker between these different stakeholders, I think can also help play a role in coordinating across the different actors. So it's to be applauded, and it's quite interesting that it's not only the scientific research that you're doing is so robust, but that you're in a pivotal position to help translate it into results.
And Eric, if I may add just one sentence to highlight what you said about the need and to bring in the local measurements and bring this also to the table, understanding better that from that side. An important component was involvement. I think I mentioned that in the presentation, also collaboration with local partners. And this is both in terms of developing or solidifying scientific understanding on the ground and jointly developing tools and adapting them to local needs, working with academia. But then there's a certain level of distrust originally, generally between policy and scientists, and different language that is spoken. So that has to, of course, evolve. But then a joint support of and development of this measurement campaign, FMI, the Finnish Meteorological Institute in Hanoi, for example, they have done it really jointly with the EPA, with the Hanoi EPA, including partially analyzing also the samples. So some of the analysis of samples was done in Hanoi, some of that was done in FMI, at FMI in Helsinki. And that joint work had delivered the trust that is needed, both on one hand in these measurements that were then communicated by local authorities, by local EPA, as well as the work that we have done on modeling that show that connection and deliver some of this by the local modelers and the local people that we worked with. This has been very powerful. So it's not we from the outside, some were telling that, trying to use our experience in developing this, for example, in Europe, but this joint work has been very important.
That's great, Zig. I appreciate you highlighting this and connecting it to the experience in Hanoi specifically. I think we have two questions, and although Professor Human had his hand up first, I'm thinking of actually going to my colleague, Professor Mao from Beijing Normal University. Professor Mao, did you have a question for Zig or the other presenters?
Oh, yes, I have questions both for Zig and Human. Thank you very much for great presentations. I have a common question for you too. My question is that in your study, did you or do you consider the indoor pollution? Because according to my understanding that either in Southeast Asia or in Mongolia, Ulaanbaatar, the indoor pollution should be an issue because people use the cooking range, burning coal or wood in their home. So in your model, in your study, did you or do you consider that? Thank you.
Why don't you take that, Zig?
Okay, so thank you very much. That's a very, very important and very good question. We do take that into account in terms of looking into the impact also on the indoor air quality. That's not one of the actual, so it is a driver for the motivation, of course, for the work. But from the perspective of how the model is operating, this is looking at ambient concentrations and, of course, measures that will deliver reductions of ambient PM2.5 and reduction of exposure in the ambient air. They will also bring in this indoor, just as you mentioned, sources like coal and also biomass cooking. They will deliver on indoor air pollution. So this is one of the elements that we are independently assessing.
Thank you. Thank you.
Thanks so much, Zig, and thanks so much, Professor Mal. And then maybe Professor Human, maybe you want to answer. I think Professor Mal was asking the same question to you to some extent, and also you might have a question as well.
Yes. Thank you very much. Sorry, maybe you can see some. You can hear some echo. What's? Oh, okay. Yeah. Can you hear me? Okay. Can you hear me?
We can hear you fine.
Yeah, okay. So just to answer the Professor Mao question, so for the indoor pollution in our estimation, no, we didn't consider. Actually, we have very rough estimation about indoor pollution for the case of HOB, but because the project for assessing the co-benefit of HOB in our side was about the basically the industrial HOB system. So we just consider the outdoor emission, but this is the plan for the future that we can include also, cooking stoves which are used inside the spatially GER area, location. Thank you for the question. So I have a question for Zig. First of all, thank you very much for accepting our invitation and joining our workshop, Zig. So following the question that Eric asked you, so I'm interested basically in the sector, transport sector. As you know, we have two different definitions for the transport sector, intercity and intracity, especially when you consider movement between two neighbors. This is really important. And I want to know your experience. How do you define the border for a city when you consider this movement? And who will be the owner of co-benefits? For example, if you consider, transportation system from one city to another city, okay? So when you try to reduce the PM emission or increase or improve the efficiency of the system, who will be the owner? If you consider intercity, rather than the intracity that the transport is inside the city. Thank you.
Go ahead, Zig.
Thank you very much. Human, that's quite a big question, actually. It's very important. It cuts across two different areas. And again, thank you very much for giving me the opportunity to talk at the workshop. So there is this question of attribution, how we do that. So I've shown very quickly a map of that we explicitly allocate spatially transport. So we try to distinguish for different sources, and actually it happens for heavy duty trucks and buses, and then more local transportation and city traffic is allocated separately. So we're trying to capture that through spatial distribution, and the model is looking into these low-level sources because we have source receptor coefficients that specifically address this local level pollution. Now, in terms of measures, the measures will be reducing emissions differently. So there will be a different signal in a way from measures within the city that could be shaped like changing some of the cars into public transportation at a local level. So we stimulate that through within the city measures, and at the same time more regional policies, which we suggest should cut across actually all of the regions. So we are not specifically suggesting that there should be a very localized policy, especially for heavy duty trucks or long distance buses, rather benefits of larger policies. This is simply beyond what we can do and model it at a very, very fine scale. So these are aggregated categories from our perspective at a larger scale. So we could think about it as a large pattern that we are then suppressing by reducing these emissions across many regions. And it's explicitly actually tagged in a way to local pollution and to this regional, say, local contribution and the regional contribution. We have not addressed this question of, attribution of benefits in a way those who benefit are the population that actually get the reduction of the exposure, but we did not think about success in terms of one government versus the other government. So rather thinking about demonstrating if city alone would pursue some of the options that would be limited, of course, against a wider scale options that cut across both city and regional collaboration, for example, heavy duty trucks. That is the way we are thinking about it.
Yeah.
But I did not explore the full depth of your question. That would require, it's a shame I cannot join you in the coffee break and we could continue this discussion. Thank you.
Thank you very much.
Okay, thank you so much, Zig and Professor Human, for a good question. I think, see if there's any other questions. If not, we have, so we're going to actually have the coffee break now. And we'll go from now, we'll make it a 10-minute break. So from Japan time 3:50 to 4 o'clock Japan time, and then we'll start with the next session. The next session will be chaired by my colleague Satoshi Kojima, and he'll also start with just a brief overview of some of the other work that's being done by YASA in collaboration with Japan. So let's reconvene in 10 minutes at 4 p.m. sharp, and then we will start the next session. Thank you so much, everybody, and really appreciate all the great presentations so far. Okay, colleagues, I think we can start our next session. And the chair of our next session is one of I²CNER's principal researchers, Satoshi Kojima. Kojima-san is working on many projects, including this 1.5 degree report project that's looking at lifestyle changes for achieving the 1.5 degree goal. He's also working on a platform for redesign that's helping to analyze how different countries are redesigning in the wake of COVID. Kojima-san, the floor is yours, and I hope to see a really good session number 2. Thank you so much.
Thank you, Eric, for your very kind introduction. So let's start session 2 about the co-benefit of climate change mitigation strategies. So before that, I introduce 3 presenters. First, I'd like to briefly introduce MOEJ, Ministry of Environment Japan, and then IASA's collaborative research project, which already Jig's keynote presentation covered, but briefly I'd like to introduce. So can you share? Oh, sorry. Okay. Yeah. Can you see the slide? Oops. Sorry. Something wrong. Yep. Okay. Yeah. So I hope you can see just one slide. So this MOEJ EASA collaborative research project, basically the member countries of EASA expect scientific outputs directly useful for national or regional policy development. And then EASA is now strengthening bilateral collaborative research project. And in Japan, there are 2 collaborative research projects between Ministry of Environment Japan and EASA started this fiscal year. So first one already touched on this project, interactions between urban and rural air pollution in Asia and the multiple development benefits of coordinated action. So this project highlights air quality and health benefits from regionally and internationally coordinated response action and explore co-benefits with various SDGs based on regional atmospheric modeling by NICE, Japan, and the regional emission inventories, ACAP, and governance issued by IGES, and then gains model of EASA. The second project is about the SDG. So it's an Asian initiative on SDG compatible national and regional decarbonization strategies. So this second project develops effective measures to maximize synergies between selected SDGs, like climate change ones, and then also like biodiversity issues, etc. And then so this second project is based on the coupling of the AIM model, Kyoto University and NICE, Japan, and the message and the gains model of EASA. So so these 2 collaborative research projects are now conducted. So this fiscal year and the next fiscal year, these 2 projects are conducted. Okay, so let's finish this one, and then so let's move to the like three presentations. First presentation is by Dr. Yorache. Dr. Yorache is a senior research fellow at the Korea Environment Institute in South Korea. So Dr. Che's research specialty is integrated assessment of climate change and air pollution. Her research interests include economic analysis of climate change co-benefits, analysis of air quality and climate change policies. And recently, she is working on development of data-based impacts-based heat wave forecast system and integrated assessment of climate change mitigation adaptation policies and policy library for air quality and climate change. So, Dr. Che, the floor is yours.
Thank you.
Sorry. Yeah.
Can you see my presentation?
Yes.
Yes, we can, but maybe better to show slideshow.
Okay. Is it better?
Now the second slide is also presented.
Yeah.
The two slides, yeah.
Yeah. I cannot solve this problem. Yep. Yeah, give me a minute. Yeah, it happened before, but just 1 second. Yeah. It is better.
Yeah, better. Yeah.
Yeah. Okay. Let me start. Hi, good afternoon. I'm Yora Che from Korea Environmental Institute, and thank you very much for giving us to participate in the project as well as this workshop. As introduced by earlier, I'm doing many integrated assessment research, and my major interest is to find and quantify the co-benefit between the policies. So today I'm going to show the importance of co-benefit and some case studies in Korea. So not just in Korea, but many parts of the world, the major risk we are dealing with right now is pandemic and climate change. So these are the recent survey in Korea. So what is the most serious risk faced by the normal life in Korean citizen? They found the pandemic risk is most important, followed by climate and economic crisis. And how do they recognize the climate risk is by natural disasters like heat wave, cold wave, and heavy rains. So like in many countries, Korea government deal with the climate risk and COVID pandemic, and they also have to deal with the economic crisis. So we are dealing with the deflation of economic development in these days, caused by climate change in some part and mainly by the pandemic. So some transformational approach is required by the government to develop on new policies and to achieve the sustainable development pathways. So that's the main reason. They have to deal with climate change risk, and they have to promote the industrial development and future green industry competitiveness. They also have to take care of jobs. So many job losses happened. And recently, Korean government declared carbon neutral by 2050. As we all know, Paris Agreement in year 2015 and IPCC special report on global warming of 1.5 degrees centigrade has been published, an emission gap report. And recently, China and Japan joined the climate neutral by 2050 and 2060. And in December, President Moon declared to achieve carbon neutral by 2050. So these are the GHG emission status in Korea. So GHG emissions continue to grow, although the emission growth rate has been declined after year 2011. And the sectoral emission source is largely occupied by the energy industries, about 39%, and followed by the energy and fuel consumption by manufacturing and construction industry and transportation. So climate change is not the only issues Korean government has to deal with. They have other issues as well. The air quality is one of the main issues. So many people in Korea are concerned. So in the past, there are separate departments and separate policies to deal with greenhouse gases and air quality. And right now, they are trying to look at both problems together, considering complementarity of each policies. So what is the co-benefit and trade-off synergies in between two policies? So, and eventually the optimal policy should be the multifunctional policies. So policies can take care of climate change, air quality, and other sustainable development issues. So trying to find the best optimal multifunctional policy for in certain region and certain country in certain time is the major research objective of mine. So these are 3 pillars of Korean policies: air quality, climate change, and energy transition. So air quality, there are special act on fine dust. So, and climate change, there are roadmaps to achieve GHG emission reduction by 2030 by 37%. And there is energy long-term eco-friendly energy transition plan. So the basic plan is the 3rd basic energy plan and 9th power supply plan. So the 3rd energy plan is, which is the highest level national energy plan. And in the past, the energy plan only deal with the energy security, so to supply energy sufficiently for the needs. Right now, the emphasis moved from energy security to safety issues, especially for climate change and air quality. So they right now take care of and consider the reducing climate change risk and improving air quality when design the plan in energy plan. So emphasis from energy security to climate change and air quality policies, and while moving and taking consistency with the special act on fine dust 2020 roadmap for GHGs, and expanding the air quality management policy focused on the metropolitan area to national level. And they also try to expand emission trading system and strengthening the market function. And these are major climate change policies in Korea. It's year 2018. Korean government established the year 2030 GHG emission reduction roadmap. The objective is to reduce GHG emission reduction by 37% by 2030. And these are the major policies, so increasing the share of renewable energy and early retirement of coal-fired power plants and limiting the entry of new coal power and transition from coal to LNG power plants. So eventually the Korean government tried to replace renewable energy, but as a bridge, Korean government to use LNG power plant. And these are the NDCs and LEDs in Korea and in global level. And because the president declared to reduce to achieve carbon neutral by 2050, so we have to change the NDC as well. So many researchers and policymakers in Korea trying to redevelop the NDCs to achieve the net zero emission by year 2050. And right now they are making many pathways, how do we achieve the net zero by year 2050 in most efficient or optimal way, which is the best way to achieve carbon neutral by year 2050. And these are the comprehensive plan on fine dust management, which is announced in 2019. So objective is to reduce PM 2.5 emissions by 36%, and major policies including the strengthening control over emission from coal-fired power plants and increase renewable energy, and total emission allowance system for industrial sector. And they introduce strict emission standards for diesel vehicles and increase eco-friendly cars, like hybrid and electric cars. And we also have the Renewable Energy 3020 implementation plan, RE 3020, because the objective is to increase the share of renewable power generation to 20% by year 2030. So it's called RE 3020. So major policies including switch from bio and waste-oriented renewable energy to PV and wind-oriented renewables, and increase the share of agriculture PV and buildings, and strengthening RPS for energy suppliers, FIT, and Eco Environmental Energy Fund. So this figure shows the renewable energy share in year 2017, and this at the objective of RE 3020 in 2030. So they plan to increase the share of PV and wind significantly by year 2030. So many policymakers in government and district government have to deal with climate change and air pollutant and energy transition at the same time. So how do we do that? What is the best way to do that? So what other synergy? This is a question that many policymakers faced by. What other synergy and trade-off between air quality policy and GHG mitigation policy? And what is the optimal policy mix to achieve goal of air qualities and GHG mitigation policy? So what are the prioritized order of policies by region and by sector? And how to maximize benefit with a limited budget? And how to policy effects would change with some uncertainties in the future, like what if the pandemic continues in the future? So how much does the integrated management to curtail the net cost? So we have to answer these questions. So and co-benefit play very important role to find that solution. So co-benefit is, you all know, the positive effects that a policy or measures aimed at one objective might have on other objective. And it is effective of the net effect of overall social welfare. So and air quality and climate policy of a country shares various social goals with neighboring countries. So we only have to consider co-benefit in our own country. We can also consider the co-benefit in our neighboring country and sometimes in global level, especially for climate change. So by considering co-benefit, it can change the optimal policy level, or it can change the order of priorities in some policy mix by considering co-benefit. And co-benefits expand the boundary is become much bigger when you only consider co-benefit from air quality and co-benefit from your own country or one region, whether you can include co-benefit from global climate change co-benefits. So it's very important how to quantify and integrate the co-benefit into policy dimension. So as a case study, we estimated the co-benefit of renewable energy policies in Korea. So we analyzed the solar PV, what are the co-benefits. So we analyzed and quantified the GHG and air pollutant emission reduction by installing 30 gigawatt solar PV in Korea. So major assumptions are PV is evenly installed from 2020 to 2030, and the total electricity demand is followed by the 9-phase plan for long-term electricity supply and demand, and it will expire after 2030. And share of coal and LNG power generation is fixed as now, and we use discount rate of 4.5%. And we quantified and monetized the GHG air pollutants and GHG and air pollutant emission reduction of installing the PV. And cost is construction cost and maintenance cost, and the social cost of CO2 and air pollutants analyzed by Korea has been applied. And these are the major characteristics of power plants by source, and coal, LNG, and PV, which has different lifetime, different capacity, consumption level, and cost and emission factors. Then we calculated the CO2, NOx, SOx, and PM 2.5 emission reduction by PV. And these are the annual emission reduction after 2030. So for CO2, 10,000 megaton CO2 could be reduced, and NOx and 10,000 tons, SOx 23,000 tons, and PM 2.5, 433 tons could be reduced by installing PV. And these are the cost and benefits of solar PV. And we shows the cumulative net cost, including co-benefits by 2045. So if we only consider cost of installing PV, the cost could be 25,926 billion Korean won. But if we consider the cost and social cost of CO2, so the benefit of CO2 emission reduction by solar PV, the cost becomes 21,663 billion Korean won. And if you consider the energy saving, cost becomes 5,360 billion. And if we consider the benefits of air quality, actually the cost to become the negative. So negative cost. So these are the conclusion and policy implication. So renewable energy is a key solution to cut carbon emissions and help mitigate climate change. So renewable energy expansion has been included in climate change policies, air quality policies, and energy transition policies. So as a net zero measures, electrification implies that the share of renewable power generation should be increased rapidly, even they're much bigger than implemented in 2020 measures. And right now, South Korea's renewable energy share is 7.6% in year 2017, and it relies heavily on waste and bioenergy power generation. The share of solar and wind energy is quite small. The crucial barrier, why is that? Because the crucial barrier to expanding renewable energy is higher cost. However, as we shown earlier, the inclusion of co-benefit and social cost of air pollutants and GHG, the renewable energy cost is not that high, because the cost is significantly lower by including co-benefit. So this case study shows the whether and how you quantify co-benefit into policy analysis and policy dimension. Actually, the priorities and people's conception of the high cost of renewable energy can be changed. Thank you. 감사합니다.
Thank you very much, Dr. Che. So your presentation clearly demonstrates the Korean climate policy and air pollution policy and how co-benefit demonstrate co-benefit is important to implement these policies. And then thank you for showing the methodology and the case study of a quantitative assessment. So any questions? If you have any questions, some clarification type of short questions, please raise your hand, or maybe you can just directly talk with your name. I have difficulty to check who I'm. Okay, so if I think there are no no question, etc., then let's move to the second speaker. Okay, so the second speaker is Etsujiro Takai. So Takai-san is a researcher at I²CNER. His research focuses on the co-benefits or renewable energy policy and the private sector engagement in climate and sustainable development processes. He's increasingly interested in understanding how the concept of regional and circular ecological sphere can overcome barriers to achieve co-benefit. So Takai-san, floor is yours.
Thank you, Kojima-san, for the introduction. Can you hear my voice and can you see my screen?
Yes, yeah, we can see your screen.
Okay.
But not slideshow.
Can you see it?
Still has the ordinary display. No, slideshow. I'm afraid. Oh.
Can you see my slides?
Yes, but has a two slides.
Okay.
Yeah.
Let me. Can I start with this screen?
I see. Okay. Yeah. Please go ahead.
Okay. Hi. And so I would like to have presentation on the title, "The Co-Benefits of Renewable Energy Policies in Japan: Barriers and Ways Forward." So this is my outline, potential for co-benefits from renewable energy in Japan, policies that promote renewables in Japan, barriers to renewable energy in Japan, overcoming barriers, quantification of co-benefits from renewable energy in Japan, and the role of regional circular and economic sphere, and conclusion at the last. Okay, so at the beginning of this presentation, I would like to explain the term co-benefits, although most of you are familiar with that concept. Co-benefits are the added benefit we get when we mitigate climate change above and beyond the direct co-benefits of a more stable climate. So if you promote renewable energy, you can get the benefit of climate change mitigation, and besides various kind of benefits like cleaner air, fuel cost reduction, independence in energy security, resilience to hazards for power plants, and stimulation to the local economy. These are called co-benefits. And I'd like to explain the policy trends in Japan. And most of you know that Japan has, in Japan, Fukushima Daiichi nuclear power plant accident occurred in 2011, 10 years ago. And most of the power plant, nuclear power plant stops its operation. And after that, we changed energy policy drastically. And for energy policy overall, in 2015, the government of Japan set the long-term energy supply and demand outlook. Intended nationally determined contribution was set based on this outlook. And in 2016, amendment of Act on Promotion of Global Warming Countermeasures was set. It stipulates the measures for reducing global greenhouse gas by 80% by 2050. And in 2019, long-term plan as a growth strategy based on the Paris Agreement. In this long-term plan, the decarbonized society should be achieved in the late 21st century as fast as possible. And very recently, in 2020 October, green growth strategy following 2050 carbon neutral was announced by Prime Minister Suga administration. And it declared decarbonization by 2050, and the sixth strategic energy plan will be issued in this coming summer. And for renewable energy policy side, in 2003, renewable portfolio standard was set. It obligates utility companies to use renewable energy for a certain rate. In 2012, feed-in tariff was set. And in this system, it obligates utility companies to buy renewable energy at a fixed price for a fixed period. And the feed-in premium system is now in discussing. And in this system, it obligates utility companies to buy renewable energy at a higher price than thermal electricity. It facilitates the competition between thermal power and renewable power in the market mechanism to aiming to accelerate further cost reduction of renewable energy. So what's the difference between feed-in tariff and feed-in premium? Feed-in tariff put emphasis on diffusion of renewable energy, and feed-in premium put more emphasis on the cost reduction of renewable energy. So for your information, this is the energy and power supply in Japan in the long-term energy supply and demand outlook set in 2015. And you can see the renewable energy ratio in 2030 is set 22 to 24%. But if you realize you achieve decarbonization in 2050, some people discuss that you need to raise the goal to 40 to 50% in 2050. So it must be revised to 2 times the current plan. And this is expected energy mix in 2050 in Strategic Energy Plan 6. So you can see in 2050, the decarbonized power source, like renewable, is expected to 50 to 60%. And so now I feel the policy is drastically changing. Okay, so next I would like to introduce the barriers that prevent the promotion of renewable energy in Japan in 3 aspects. I mean the technical barriers, social barriers, and political barriers. In technical barriers, first, unstable generation. As you know, the renewable energy depends on the condition of climate. So nature condition, like amount of sunlight or wind. And next, system constraint. If the electricity supply and demand balance would collapse, it harms electricity transmission system, such as system equipment. Next, dominated transmission line. Currently, transmission system is occupied by utility companies. So there is limited capacity available for renewable energy companies. Next, social barriers. Limited space. You know, the land of Japan consists of steep and limited plain land. So there is limited space to introduce solar panels or wind turbines. And next, public nuisance. Installment of solar panels or wind turbines causes nature destructions like forest, river, or beautiful landscape, and damages wildlife, such as birds. And high cost. People oppose renewable energy installment because it causes electricity cost up. Then the barriers of political. Objection from general electric utilities. Historically, utility companies objected to install renewable energy because it is regarded as competing with existing thermal power and causes additional cost. And then RPS system was established. Amount of obligated purchase was too much limited, so it suppressed the introduction of renewable energy. Next is the overcoming barriers. So as you can see in this diagram, it shows a balance beam between thermal energy and renewable energy. Each energy source has its benefit, its advantages. For thermal energy, short-term cost competitiveness and stable generation is expected. And for renewable energy, climate conservation and renewable resource independence and regional circular and economic sphere are expected. So these are called co-benefits. So how you can persuade policymakers, politicians to decide introduce more renewable energies. The barriers will be cleared by advance of technology like generation capacity and battery storage capacity, or cost reduction. And the key factor is the evaluation of co-benefits. So this is called quantification. In this chart, I calculated the quantification of co-benefits when you transit from thermal power to renewable power. And in this chart, I assume that renewable energy will increase straightforward from current pace to 2030. And the amount of PM 2.5 was calculated by multiplying emission factor and amount of generation. So you can see much amount of CO2 and PM 2.5 will be reduced by replacing current liquefied natural gas and coal-fired power plant. Next, I would like to introduce the concept of regional, circular, and economic sphere. In short form, you can call it regional CES. And in 2018, April, government of Japan launched the idea of regional circular economic sphere in the 5th basic environmental plan. The concept of regional CES is that local communities make full use of regionally available resources to realize an independent and decentralized society while complementing and supporting the local resources with neighboring areas. It is ideal that rural community make use of its natural resources for renewable energy and stop relying on utility company. Urban area and rural area can complement and support each other in what they need, like human resources and natural resources. It aims to solve complex economic, environmental, and social issues simultaneously. If you create employment by renewable energy in rural area, it will stimulate local economy and keep population and mitigate climate change. As some of you know, Japan's population has continues to increase since the end of World War II, but since 2005, it has peaked and it is decreasing. In Japan, especially in rural area, rural communities where there is not much employment, there are many cases where younger people transfer to the city and then they never they enter colleges or get a job and do not return to their birthplace. The local population is rapidly decreasing, and because of the declining birth rate and the overflow of the people, creating employment is important for regional revitalization, and this requires keeping young people in rural areas and preventing population decline. Renewable energy is one of the few growing industries that can create jobs in rural areas. And I would like to introduce one good example of regional CES in Shimokawa Town, Hokkaido, Japan. So, as you can see, Shimokawa Town is located in the north part of Hokkaido. So it's located in very cold place, and you can see the population peaked in its 1960s and decreasing rapidly. The town used to prosper in 1960s by its production of timber and agriculture, but now the population is decreasing, and about 40% of the population is now over 65. So it's the typical case of aging society in Japan. And you can see this kind of community in every place in Japan. And the main industries are forestry and agriculture. And so you can see the people are discussing about their what it is like the town wants to be in the future. And it builds the concept of circulating forestry management. So this is the case in Shimokawa Town, and sustainable community design. And it produces Forest Stewardship Council certified wood. It is a proof of wood produced in socially, environmentally, and economically sustainable manner. And they, as you can see in this right side, this is called Ichinohashi Bio Village. And this is the concept of compact village to solve the transport problem. About 19 people, most of them are aged people, are living together. There people utilize biomass resources, such as timber material, in biomass cogeneration of heat and electricity, and making up for electricity consumption or room heater or hot water production and others. So it aims to simultaneously solve the society and the environment and economy problem at the same time. So it got the first Japan SDGs Award Grand Prix in 2017. The activity of Shimokawa Town is highly evaluated. Okay, so the conclusion: renewable energy introduction deliver various social, economic, environmental co-benefits at the same time. And these benefits are often not visible to policymakers. And quantifying these co-benefits can make them more visible and understandable, and make policymakers understand and help overcome barriers to renewable energy in Japan. Concepts such as regional CES can also help overcome these barriers by clarifying the linkages between multiple social, economic, environmental issues. Thank you for your listening.
Okay, so thank you very much. So it's interesting to see some commonality and the difference between Korean case presented by Dr. Che, and then Japan case presented by Takai-san about this has renewable energy related co-benefit. Okay, so any questions? If not, okay, please.
Zig here. Can I have two quick questions, one to the previous presentation from Korea there was a notion of internet impact of regional policy and adding to the benefits if regional cooperation is included. I was wondering how is it included in this modeling? What kind of assumptions are taken there in terms of regional collaboration, say within Northeast Asia? And the question to the last presentation, I was wondering if the example of this village, a very interesting example, has been followed by other communities across Japan. Did it steer a pickup of this kind of thinking locally?
Okay, thank you very much. Okay, so the first question to the Dr. Che about like regional co-benefit questions.
Thank you for the question. The regional co-benefit has not been explicitly included in this analysis. However, it has been included in the social cost. The social cost of carbon dioxide is the marginal benefits of marginal damage of CO2 emissions, and we estimated the global CO2 climate change damage. And for the air pollutant social cost, we only consider the social cost or damages of 1 marginal ton of air pollutant emission, but we only consider the damage in Korea. However, if we consider the emissions of air pollutants from Korea to other countries, the social cost will become higher. And the cost-benefit ratio, the benefit of renewable energy or any emission reduction policies could be higher. Thank you.
Thank you. Then the second question to Takai-san about like local issues.
Yes, thank you for the question. And in this case of Shimokawa town, the people, citizen, decided to fully utilize their natural resources of wood because the Shimoka town is full of plenty of wooden resources. But many places of Japan, there are specific natural resources exist. So in some place the sunlight, and in some place the wind. You can introduce many wind turbines, like in some place of Hokkaido. So you can decide what natural resources to utilize depending on its specific social and environmental and economical situation.
Okay, thank you very much. So now time is limited, so let's move to the third speaker. By the way, Takai-san, could you stop sharing? Okay, thank you very much.
Okay.
Then, so third speaker, Mao Shanchen. Mao Shanchen is a professor at the Beijing Normal University in China. His research interests include environmental and natural economics, environmental impact assessment, environmental planning and environmental policy and management. And he has engaged in several projects and publications on co-benefits in China, including a recent ADB project on co-benefits in China's transport sector. So Professor Mao, floor is yours.
Thank you very much. Now, are you able to see my slide now?
Yes, yeah, we can see your slide. But if possible, could you start at, yeah, perfect. Thank you very much.
Okay, welcome. Good afternoon, dear colleagues. Many thanks for inviting me to join this very important event. And today I'm going to share with you the piece of research that we did under the support of I²CNER, essentially last year, quantifying co-benefit from solar energy policy. So I'm going to just focus on solar energy, not including other renewable energies. Okay. I'm going to share with you some of the information about the solar energy use in China and the plan and policies to support solar energy in China. And we did a rough quantification of the co-benefits from solar energy use here in China. And I'm going to talk a little bit about the piece of new study about the global PV trade goods. And finally, the challenges and suggestions. For the solar energy in China, you can see here the allocation, spatial allocation of the China's solar energy potential. Actually, in China, in the vast majority of the territory in the west, where there's very few population and high plateau, the energy solar resources is very rich. However, it's quite far away from the east part, where the economy and the population are concentrated.
And, sorry, by the way, could you turn on your camera?
Oh, yes, yes.
Yeah, please. Yeah.
Can you see me now? Okay. Okay.
Oops. Yeah. Oh, yes, yes. Thank you very much.
Okay, welcome. Sorry. Here are some of the photos we took during our on-site investigation. And you see there in the past decade, there's already a lot of installation of the PV photovoltaic stations, and also some of the rooftop utilization or distributed allocation application of the solar energy PV use. And we see the increase of solar power installation capacity increased very quick during the past decade. And you see the increase rate is very high. And we actually have a goal for 2020, 5 years ago, but actually this target have already been achieved 2 years or even 3 years ahead to the schedule. And in 2018, the installed capacity of solar power reached 174 gigawatt. It's nearly 10% of the total installation per capacity. However, the power generation is the proportion is much less than the capacity installation, with just 2.5% of the total power generation. That's the investment increase of the PV power in China. And we say in 2013, there's a high jump of the investment on PV solar power generation. And the government think there could be an overheat there. And then they announced several documents to restrain the overheat of the investment in this area. But still, after 2014, you see a consequently increase of the investment in this sector. And although there's a lot of huge increase of the installation of solar power, the still some of the problem of the power grid to incorporate all those solar power from faraway areas into the grid. And so we can see that in 2017, 2018, and even early 2019, we see a lot of waste of solar power generation. And we see there was 60%, 3%, or 1.9% of the wasted solar power, which cannot be connected into the grid. However, this problem has already been gradually solved, and we can see a decreasing of those waste already. The other part of the estimation is for solar heating, which is a very traditional use of the solar energy. And we see this is a solar heating system on rooftop of Beijing. And we see in rural area, we see a lot of this type of solar heating system to produce warm water or to heat waters. And for the solar heating system in China, we see also in early years, in 20 years ago, there's a lot of expansion of this type of utilities in the rural area. However, in the past several years, we see the increasing rate has already been flat because we essentially see the population in the rural area of China is decreasing, and there is less and less incremental of this type of installation application of solar heating. And we see Chinese government did a lot of effort to promote the development of solar energy use. And we say from as early as 2005, we see a series of policies plans being announced by the government. Until now, we see we have a law of renewable energy, which was published in 2005. And to the last year, 2020, we still see the notice of the feed-in tariff policy of PV power generation. So even until now, we still have the feed-in tariff support to the PV power generation. This is the on-grid or feed-in tariff policy for China. We can see here that the whole nation was divided into several types. For type 1 area, type 2 area, and type 3 area. For those three parts, we have different feed-in tariff rate. And here we see the lowest blue curve line represents the type 1 resource area, which has the lowest feed-in tariff subsidy for the PV. And we see in type 3 area, we have the highest feed-in tariff rate. And until the 2020, we still have this much of feed-in tariff subsidy for the power generation, but the government has decided to gradually reduce the subsidy for power generation because of the decreasing cost of those solar power, PV power generation. We also have set up the target for the future development of PV power generation for the installed capacity and also solar power generation. We see for 2020, the planned installation target is 110 gigawatts, but this already being reached by 2018. It's already 174, and also similar for the solar power generation. The target is 140, but actually in 2018 it's already 177. But the problem is for the solar heating, it was planned to be 800 square kilometers, but actually in 2018 it's just 482, and it seems quite difficult to meet the target already. But for the future, up to 2050, we see the increment of the installation and power generation is very quite ambitious, and we can see here this gives the impression of how large the scale of the PV power installation and generation will be. And we did a quite rough quantification of the co-benefits from solar energy in China. Well, very similar as other researchers from our colleagues from Korea and Japan. We consider solar energy use. We consider this type of energy, solar energy use will replace or save energy, roughly, basically the fossil fuel energy use, and that will help us to cutting down coal consumption and promoting cleaner electricity, and that will bring down the carbon emission and local air pollutants emissions. And what we consider is about the CO2 emission and also SO2, NOx, and PM. Here are some of the co-benefits estimation parameters set for this study. We divided into solar PV and solar heating, and we set the assumption for the energy saving co-benefits. We set this carbon emission per kilowatt hour. We see that it is assumed to decrease over the projection years, and also similar for the solar heating energy savings. And we can then calculate the local air pollutants emission reduction coefficients, and we can also calculate the CO2 emission reduction coefficients. And then we also use this formula to calculate, to estimate the co-benefits valuation or monetary valuation of the co-benefits. Here we simply use the 2018 price term, and here for simplicity and to highlight the importance of the future, we just simply assume that discount rate is 0. So in that way, we can just simply add up all the future emission reductions and monetary benefits. And for the price terms, we have the energy price here. This much of RMB per ton coal equivalent, and we also have the price for the local air pollutants emission reductions for the SO2, NOx, and PM. And this price term is just borrowed from the Environmental Protection Tax Law of the PRC, and we take the highest price level for our calculation. And we also use the carbon emission reduction price. We borrow the carbon price from the carbon trading system of Chinese carbon market. And here, here is the co-benefits from solar energy in China, including energy saving, air pollution reduction, and carbon mitigation. And here we see that in the prediction of the 2050, we will have nearly 2,000 megaton carbon equivalent per year reduction, and we also have the local air pollutant emission reduction for this much of megaton per year, and the carbon emission this much of emission reduction. And this is the diagram for the energy saving or production benefits. The blue part represents the solar PV power generation, and the yellow part represents the solar heating. And this is the carbon mitigation benefits potential up to 2050. And again, this blue part represents the PV power, and this is for heating. And this is the event benefits of local air pollutant reduction. And we see that this is blue, this is for PV power, and this yellow is for solar heating. We see that here the estimated solar heating cause local air pollutant reduction is much higher than its ratio, its proportion in the combination here, in the composition here. And this is because we assume that the solar heating will replace some of the heavily polluting coal consumption types. For example, in the rural area, people use the coal to heat, to cook, and we assume that the solar heating will be able to substitute, to replace those type of heavily polluting ways of using coal and biofuel, biomass. That's this summary of the co-benefits evaluation physically here. And we also can monetize the co-benefits of energy saving and local air pollutants emission reduction and carbon emission reduction. And the total you see here, which is extremely high estimation, is nearly 1,060 billion RMB per year, which is quite impressive. And we see here is the energy benefit in monetary terms. And we see again the PV, the solar PV power generation takes larger part of the total, and for the heating is less. And that is the CO2 reduction benefits in monetary terms. And this is environmental pollution reduction benefits. And again, we say that the carbon reduction here takes a larger part of the total benefits here compared with local air pollutants emission reductions. So that means we essentially will achieve global, much bigger global benefits in terms of monetary terms, and that to help us to contribute to solve the global environmental problem. And this is just a diagram to impress our audience that from 2018 to 2050, the increase of the monetary benefits of those both global and local benefits could be. And well, that's again a summary of these co-benefits evaluation results, and that will be 1,060 billion RMB in 2050, which will be 14 times larger than that of 2018. And another piece of work we did recently is to estimate the co-benefits from traded PV goods. And first, we illustrate the global PV product trade flow, and we see that in 2017, 2014, this March of PV solar cells and modules being traded globally, and we see large part of that is exported from East Asia and exported again. Most of them goes to East Asia. But if you look at 2017, the much more diversified flow of those PV goods to different areas of this world. And we see again, East Asia contribute a lot to the other part of the world. And this is the emission potential of traded solar cells and modules. And again, we see East Asia can contribute to global carbon mitigation by exporting the solar cells and modules to other parts of this world. And we can say that in 2017, the traded solar cells and modules can produce about 1,200 million tons of GHG emission reductions, and also quite a lot of local air pollutant reductions being brought about side by side simultaneously. And
sorry, sorry, time is running. So could you try to finish as soon as possible? Thank you very much.
Oh yes.
Sorry.
Yes. If we project to 2050, we say there will be a huge increase globally of the PV installation, and much of that will be contributed by the traded solar cells and modules. But if we consider that there will be barriers on PV goods trade, such as a trade war between US and China and among other countries, then this type of mitigation potential will be largely reduced by this much and by this much. Okay. So finally, challenges and suggestions. The first challenge would be the subsidy will keep decreasing for power on grid or feed-in tariff in China. So in that part, we propose to increase the research and development to reduce the cost of power installation and generation. And for the second challenge is the land occupation. Even though that China has a vast territory, but the land appropriate for installation is still quite limited. And we propose to use the urban buildings to enlarge the area to install the PV applications in the roof and in the south walls. And again, the heating is becoming less and less because the rural population becomes less and less. And in that way, we propose to use the solar heating for industrial use to increase the application. And finally, we say that there's trade protectionism and trade barriers on PV goods ongoing. And we propose to strengthen the international free trade system rebuilding and to strengthen the negotiation on freer trade on PV goods. And the good news is that China has announced the commitment of carbon peak before 2030 and carbon neutrality before 2060. And there's a new commitment of installation of wind and solar power. And we see that the stock market performance of those PV companies, and we see the price of the stock as to rookie high like this way. So finally, many thanks for funding support from I²CNER and comments and suggestions from Eric Zuzman, Dr. Eric Zuzman, and thank you very much for listening.
Thank you very much, Professor Mao. So yeah, so it's really interesting to see the China's case, particularly like inclusion of solar heating systems, co-benefit, and then also trade issues you raised. Thank you very much. Everybody, sorry, now time is very pushing. So if you have any question or comments, please use chat Then let's have a 5 minutes break. So now the time is 5:15. So quarter past. Sorry, quarter past 5. So let's back here. 20 past 5, 5:20. And then session 3 will be moderated by Dr. Subhash Bhattacharya. He's a professor of the Montfort University, UK. So please come back 20 past 5, 5:20. Thank you very much. Okay, so
Yeah.
please back to
Shall we
session.
start?
Yeah. Yes, yeah. So session 3, Professor Sylvester Bhattacharya will moderate. So yeah, floor is yours.
Okay, so I'm Sylvester Bhattacharya from the Mumford University in Leicester. I chair this third session on new perspectives on co-benefits. I'm very happy to be attending this session because we worked with IGS, particularly with Eric Chessman and his team, on a networking project for between UK and Japan, which looked at similar issues on aligning climate actions in cities and the SDGs. So from that angle, this symposium is very, very relevant for the work that we all did. And I'm learning and I'm quite keen to listen to the presentations of this session. So there will be 3 presentations in this session. The first will be presented by Kohei Hibino on Japan's low carbon technology collaboration with Southeast Asia, co-innovation and co-benefits. Then the second one is presented by Dr. Koharu Akahoshi, and this will be on biodiversity co-benefits from analytical to action-oriented research. And then the third will be by So Young Lee, creating social co-benefits for sustainable and just society. So let me invite the first presenter, Dr. Kohei Hibino, to present his talk, and we then will go to the next presenters. Please keep within the time because we've got 1 hour, and if we have some time for question and answer, that would be good as well. So, Dr. Kohei Hibino, please.
Thank you, Chair. Good afternoon, everybody. My name is Kohei Hibino from I²CNER. Actually, this presentation was supposed to be presented by Dr. Nanda Kumar of I²CNER, but he had urgent issue matter and he could not attend today. So he just passed this role to me today. So, and I was attending several other meetings, so I just jumped in a few minutes before. So sorry, apologies that I'm not following the discussion so far, and I might not presenting as good as he does, but I will try my best. So let me share the slide, just a minute. So can you see the slide? Okay. So my presentation is titled Japan's Low Emissions Technology Collaboration with Southeast Asia. This is co-work by Dr. Nanda Kumar and Dr. Bao, Dr. Akagi, and myself. I will be talking about what co-innovation is all about and how it relates to co-benefit, how it links to co-benefits, and explain briefly about how our approach used in the research. And I will be showing 3 case studies from 3 Southeast Asian countries, Indonesia, Vietnam, and Cambodia, and conclude my presentation by takeaway points. I just have been involved in many projects, low carbon emission technology transfer project, which is trying to transfer Japanese technology to Southeast Asian countries. And unfortunately, we have been, most of those projects has been through the conventional linear approach of technology transfer, which is that the funding and technology comes from Japan, and that technology will be tried to installed to the recipient country as it is mostly. And we face many problems, like mostly the costs are too expensive, especially if it's export basis. The technology is too sophisticated, so there's an issue of a maintenance or operation. And most often, it's not, the technology is not suited to the Southeast Asian market. Most often, it's too much automated. Maybe it's good for the developing country context, but where the labor is more cheaper, it may not be applicable. However, the developing countries still definitely has needs and the markets for the low emission technologies. And especially under this COVID-19 situation where all the countries are under the economic crisis, they need a quick economic recovery, and that they do not want to be a consumer, continue to be a consumer, but they would like to be a developer or a supplier of the technologies. So the question is how do we do that? So in order to enhance the technology transfer, appropriate technology transfer, we are proposing a new concept called co-innovation. So co-innovation is defined as a collaborative and iterative approach by two or more partners for jointly innovating, manufacturing, and scaling up the technologies. So we are there are three phases in the co-innovation: collaboration, co-innovation, and outcomes. So for any project development, we need a good collaboration. And in this case, the source country is Japan and the recipient country is some Southeast Asian countries. And mostly the source inputs are a hardware on advanced technologies, advanced low carbon technologies, and the recipient inputs are more on a software aspect, are like a market or the local knowledge. And based on good collaboration and agreement to collaborate, we will enter into the co-innovation phase. The project development of co-innovation usually takes these 4 steps, starting from co-design and co-development, co-production and co-manufacturing, co-monitoring and evaluation, and scaling up and co-learning. However, it is to be noted that the co-innovation doesn't necessarily have to follow all the 4 steps. The entry point could be start from anywhere, like if the co-design and co-development is already well developed, then it could start from the co-production and co-manufacturing. And through this co-innovation and reducing the cost or the product being adjusted and modified to adapt the local needs, then we can expect better outcomes where source partners can benefit with wider market presence or available to scale up, to have co-ownership, and while the recipient partner can benefit from enhanced local manufacturing, employment generation, and able to scale up. So what is the relationship between co-innovation and co-benefit? The intended objective of technology transfer is often economic basis from both sides. So the source partner and recipient partner basically their initial intention is economic, but through identifying the best match between the source partner and the recipient partner and developing through co-innovation, we can expect that the recipient partners will have several benefits like enhanced skills and knowledge, job creation, contribution to local economy, and GHG emission reduction, and so on. So that is definitely the core benefit, including environment, economic, and social aspect. And we, in return, we expect that there will be a further incentivizing the core innovation. So in our research, we've made this kind of matrix to identify the so we made this common framework to identify the extent of co-innovation and co-benefit. So the left hand is the 4 stages of co-innovation entry stages: the extent of collaboration, expected project outcome, and achieved outcome, and that is divided through into source partner, recipient partner, and the aspect of co-benefit. So from here, I will be explaining 3 case studies. The first one is from Surabaya city in Indonesia, which is the 2nd largest city in Indonesia. And this is through city-to-city collaboration between Kyushu city of Japan and Surabaya city, which is sister city relationship. Surabaya city had a waste crisis, and Kyushu city sent an expert whose name is Dr. Takakura, and they've developed locally appropriate composting method. And through that, they could contribute to 30% reduction of waste in 5 years. So the co-design and co-development, it was developed with input from the local NGOs and lots of feedback from the communities. For co-production, manufacturing, and monitoring evaluation, it's not relevant. However, the co-learning and scaling up, the method was improved through co-learning, and the method was replicated to so many other cities in Indonesia and other countries. The expected outcome is that it contributes to the recycling of Surabaya. And here are I won't go into details, but there was lots of achieved outcomes, including 30% reduction of waste, and contributing to greening of the city and creating job opportunities. And the co-benefits were the GHG reduction and through transportation, reduction of transportation and methane emissions from the landfills. The second case study is from Da Nang city in Vietnam. It's a key city in the central Vietnam. This is through city-to-city collaboration between Yokohama city and Da Nang city. And the project was to replace an old water pump, which was inefficient, and to a high efficient new pump. And it wasn't just through replacing new equipment, but more than that, they've worked together to customize into the local context and developed like monitoring methods. So the co-design and co-development was between the DAWACO, which is Water Supply Joint Stock Company of Da Nang, with the Japanese partner. And they've developed not just replacing the system, but they started from the design and adapting to the specific local conditions, developed the monitoring and evaluation and operation system, and monitoring data is stored in a system called SCADA. And so the development of a new water pumping system was developed, and for the source partners, it could be the opportunity was then replicated to other cities like Ho Chi Minh and Hue. And for the recipient country partners, it contributed not only for the efficient supply of water, but also contributed in cost reduction of the local government budget. And the core benefits were improved stability of safe water supply and supply of water, and also greenhouse gas reduction. And the third case study is from Phnom Penh city, which is the capital of Cambodia. And this was through JICA project, technical assistance, again, city-to-city collaboration between Kyushu city and Phnom Penh. And this project was to provide technical assistance to improve the water supply, water piping system, because before the start of the project in 1993, the water supply rate was only 25%, and non-reverse rate, which is the water is stolen or leaked, was 72% in Phnom Penh. But after the project, the non-reverse rate reduced to only 8%. So only very, very limited leakages. Water supply rate went up to 90%. The water bill payment, it was below 50% before, but it's improved to 99.9%. So everybody paying the bill. And the most remarkable thing was that through this development, the water, before it was, water could not be drinkable, but it is now drinkable, and it is being, because of that, it's being called a miracle of Phnom Penh. The co-design and co-development aspect is that the PPWSA, which is Phnom Penh Water Supply Authority, and JICA and Kyushu city work really together from the development, how to install, developing like locally suited manual methodologies, and the result is that the success of Phnom Penh lead to expanded replication of the system to 9 regional cities in Cambodia. So the source partner the Kyushu city could build their government officials' capacity through this project, and JICA could contribute to the development of the recipient cities, and the Phnom Penh government could improve the water security, recover basic infrastructure, improve institutional capacity, and the core benefits were GHG emission reduction due to drastic reduction in water leakages. So with that, the takeaway points of this case studies is that the promotion of appropriate technology in developing countries is not only critical for achieving climate mitigation goals, but also relevant in the context of COVID economic recovery. While advanced technology is crucial for helping a country move towards low carbon development, making these technologies locally adaptive, suited to the local context is very important. And the key to unlock the potential of technology transfer is to work towards a co-innovation process as presented, and co-innovation accelerates core benefits with the later incentives, co-innovation in return. So that's all for my presentation. Thank you very much for listening.
Okay. Thank you. Thank you, Dr. Hibino.
Okay, we'll reserve the questions towards the end if we have time. Otherwise, the participants can send their questions to the chat box and we can take them up. The next presentation is by Dr. I²CNER. This is on biodiversity co-benefits from analytical to action-oriented research. Dr. I²CNER, please.
Thank you very much for your kind introduction. Let me share my presentation. Okay, oops. Do you see my slide?
Yes, we can see your slides.
Okay, thank you very much. Hi, I am Kaoru I² from I²CNER. Thank you for this opportunity to present our recent study. What I and my colleague Eric Zussman tried to do was to expand our scope of attention from conventional air quality related co-benefits to other fields. We are not biodiversity experts, first of all, but as co-benefit experts, we did look into biodiversity co-benefits in order to provide an additional input on co-benefits. Okay. Yeah. Firstly, this chapter, my presentation actually, provides an overview of the origin of interest in biodiversity co-benefits, noting that increases in interest are often associated with milestones in major international processes. It then underlines both the scientific, economic, and political rationales for recognizing these co-benefits in a variety of decision-making processes. It follows the illustration of some of the main entry points for achieving these co-benefits. Then it reviews a representative sample of studies that work from different entry points or employ the synergies trade-off perspective and provides concluding thoughts. Okay, let's start with the history of biodiversity co-benefits. So that the year 1992 saw the establishment of two important international conventions, namely UNFCCC and the Convention on Biodiversity, CBD, at the UN Conference on Human Environment. The objective of this CBD are the conservation of biological diversity, a sustainable use of its components, and fair and equitable sharing of the benefits arising out of the utilization of generic resources. Each of these conventions discussed targeted issues separately. Then the COP5 to the CBD highlighted connection between climate change and biodiversity for the first time in 2000. This connection was illustrated in a decision of this meeting that pointed to climate change as a key cause of coral reef bleaching. In 2002, the IPCC published a technical paper that brought this link more sharply into focus. And then what triggered an even bigger discussion was REDD+. At the UNFCCC COP13, held in Indonesia in 2007, one of the key themes was how to reduce GHG emissions from deforestation and forest degradation. With the advent of REDD+, these would be even more convergence in the substance of the UNFCCC and CBD processes. For example, the decision at the CBD's COP12 in 2014 called for the recognition of the fact that biodiversity and ecosystems are vulnerable to climate change. The next year, the Ramsar Convention on Wetlands, COP12, underlined the role of wetland ecosystem in disaster risk management and source of livelihood that could increase resilience. Then the connection was made even more concrete in the year of 2015's Paris Agreement, that is now the key international climate agreement with reference to ecosystem in Article 5 and adaptation measures in Article 7. Okay, then this slide shows an outline the natural science, economic, and political reasons why biodiversity co-benefits should be considered more actively. So natural science is increasingly showing that climate change and biodiversity are closely related. And I'd say also shows that like climate change is likely to become one of the most significant drivers of biodiversity loss by the end of the century. And on the other hand, biodiversity can reduce the negative effects of climate change. Conserved or restored habitats can remove CO2 from the atmosphere, thus storing carbon. Conserving ecosystems, including their generic and species diversity, is essential because ecosystems play a key role in the global carbon cycle and adapting to climate change, including disaster prevention. At the same time, they provide ecosystem services that help sustain humanity and development. For the economic and financial consideration, for many policymakers, if they can integrate measures to address these two issues, then they may be able to reduce the total expenditure, total cost, and expect higher cost effectiveness compared to tackling these measures separately. Okay, this figure shows possible linkages and inform potential interventions as illustrated here. There are two potential categories of actions through which biodiversity co-benefits can be achieved, namely climate change and biodiversity entry points. So if approaching biodiversity from the climate change side, from the bottom of this figure, a few possibilities merit attention. For example, a renewable energy project could protect rare species and fauna if carefully designed with these conservationist ends in mind. And making efforts to build resilience or adapt to climate change that could have useful effect on marine or terrestrial ecosystems and the living creatures inhabiting them. The other possible approach would be through biodiversity entry point. This includes interventions that protect marine ecosystems that can simultaneously build resilience and facilitate adaptation to more intense storms and sea level rise. And another set of entry points involving preserving terrestrial ecosystem, which could deliver additional benefits for storing carbon. Okay. In order to maximize biodiversity co-benefits, there have been several studies to have worked from a climate and biodiversity entry point or employed a more balanced synergies trade-off view. As for the biodiversity entry point, identifying where and how biodiversity benefits overlap the climate benefits has helped understand the dynamic interplay between both sets of concerns. Several researchers have tried to quantify the impacts of carbon sequestration on biodiversity conservation. Others are more oriented to spurring actions on the ground. The second set of studies take climate change as a starting point, including the Red Plus approach. It discussed the optimal approach to bring additional benefits for biodiversity into a mechanism intended to preserve carbon sinks. A subset of studies employs a more balanced framework for considering climate change and biodiversity synergies and trade-offs. In one such study, the starting point is how sharply increasing global demand for biomass, for energy and materials can affect climate change and biodiversity. Another set of studies involved ecosystem-based adaptation to help local communities adapt to adverse impacts of climate change. And another set of study discussed why carbon and biodiversity conservation are not easily interlinked by explaining the fundamental ecological differences between carbon and biodiversity. Therefore, this study advocates decoupling approach rather than seeking co-benefits coupling approach. This also provides an important insight to be further assessed and considered. The concluding part of this chapter recommends how the gaps between more analytical and applied approach can be narrowed at different levels. At the international level, a possible connection involves the global processes of the UNFCCC and CBD. The expanding amount of research on these linkages between climate and biodiversity suggests a need for strengthening the integration between these two processes. For example, like greater efforts to have sessions, this could involve, for example, the greater efforts to have sessions on biodiversity at the UNFCCC and climate change at the CBD. As other strides could also be made by reporting on policy integration, especially the NDCs under the Paris Agreement. At the national level, a useful bridge would be to make a concerted effort to integrate climate change concerns into biodiversity policies while also integrating biodiversity concerns into climate policies. The obvious opportunity for this integration are the nationally determined contribution, NDCs, that countries have pledged to the UNFCCC. An additional area that is likely to have meaningful impacts involved COVID-19 stimulus packages. In the wake of COVID pandemic, many governments are recognizing the needs to focus more on biodiversity. So stimulus packages that direct resources to research on biodiversity and or climate change can be structured to look at policy design that address both biodiversity and climate change. At the local and community level, one way we can start with is to support communities with the tools and resources in order them to understand the benefits of protecting biodiversity and addressing climate change. Disseminating such tools has the potential to lower the cost of data collection. It can also help empower communities to identify their own context-appropriate solutions to climate and biodiversity problems. And hopefully, it can lead to stronger connection with other social concerns too. As this example implies, there is a need for not simply integration. There is a need for not simply integration between climate change and biodiversity, but between the local, national, and global levels on these issues. As previous speakers discussed, again, both forms of integration, horizontal and vertical, will be crucial for advancing action of biodiversity co-benefits. As a researcher myself, I'd like to go further research on how to integrate research on governance at different levels with research on biodiversity co-benefits. And this is the key message. And thank you very much for your kind attention.
Thank you, and thank you, Dr. Takahashi, for your presentation.
Thank you very much.
We will wait for the final presentation, and then if you have anyone has got any questions, we will take the questions afterwards. So I will now invite the third presenter, Dr. So-Young Lee, to present his topic, creating social co-benefits for sustainable and just society. So the floor is yours, Dr. Lee.
Yes, can you see my slide?
Yes, yes. Yes, you can see your slide.
On the screen, do you see my face there? No, not the picture, but my, I'm alive, I mean.
Yeah, we can see.
Okay. Thanks, moderator. Hello, I'm So-Young Lee at I²CNER. And let me deliver a very last presentation today. And I think we are very much behind of the schedule. So I will try my best to go as fast as I can. Okay, so for the book, I was in charge of chapter for social co-benefits that entitled Creating Social Co-benefits for Sustainable and Just Society. It should be full slideshow. Good. And to follow the order, same as my chapter, let me start with this presentation, very brief analysis of the origin of social co-benefits in climate negotiations. And reviews of social co-benefits cases will follow, from inclusive ridership for low elderly citizens in the Philippines and Japan, and energy creation with women and locals with Vietnam and Laos PDR. Then we'll cover Korean case of low carbon city through participatory governance. Then we'll conclude by sharing useful means of implementation to achieve social co-benefits that policymakers should further consider. That is approach of multi-level, multi-benefits with citizens' active engagement. Well, as Eric already mentioned in introductory session, and also other speakers notified, both Sustainable Development Goals, SDGs, and nationally determined contributions highlight emphasis on interrelationship between climate change and social goals. So the achievement of co-benefits with extended consideration on social dimension, that is, I think, social co-benefits of climate crisis, is timely matter. And as we've seen from previous presentations, co-benefits are achieved. For instance, from Human's presentation on heat-only boiler project, we see the reduction of GHG and other air pollutants. More important factors beyond is cleaner working condition for workers and improvement of their health. That is social co-benefits. And besides, the reason why we should highlight more on social co-benefits is that climate crisis, unfortunately, has widened social inequalities. There are empirical findings prove those who did not produce any contributions to climate change become subject to its concentrated adverse effects. So the range of social co-benefits cover not only cleaner working condition or green job creation types, but also equity issues, such as consideration and inclusion of marginalized groups of people like the poor, the elderly, and gender impact, and more. And this emphasis on social inequalities in international climate negotiations is also a lot welcomed recently. The linkage between climate change and sustainable development traces back more than 2 decades, since international climate change negotiations concerned beyond reduction of GHG emissions. One of the most noticeable results of this effort was CDM, Clean Development Mechanism, defined in Kyoto Protocol in 1997, especially to promote sustainable development in host countries. And as mentioned several times today, the announcement of SDGs marked as a memorable turning point in the history of sustainable development. The other noticeable establishment of international climate finance mechanism that promote co-benefits is Green Climate Fund. Its proposal itself, as you can see on the slide, requires to offer clear narrative that outlines potential co-benefits beyond mitigating GHGs and request social co-benefits and gender-sensitive development impact in it. Hence, consideration of whether to include social co-benefits or not is no longer the option, as it is a requested component for most of projects and programs from international donors and development agencies. It's not deniable that it is a complex task to conduct social assessment of co-benefits when local conditions and their policy implementations are various. So in this case, it would be useful to investigate good implementations of social co-benefits, and those lessons learned from existing cases could encourage more projects and policies deliver these potential benefits. So here are a few cases. One is on inclusive ridership for low-income and elderly citizens. As you all know, transport sectors in Asia has faced a long list of negative externalities, from worsening congestion to increasing GHG emissions due to rapid urbanization and motorization. And that metropolitan Manila in the Philippines suffered same. So the National Climate Change Action Plan supports integrated transport master plan that covers non-motorized transport, that is bicycle sharing. Most of the benefits you can assume is shifting short distance trips to bicycles that obviously reduce emissions and also cost effective. That's the co-benefits of bicycle sharing. But more important part is social co-benefits, as it provides better accessibility and connectivity to public transportation to low-income individuals. Those significantly rely on bicycle sharing without the needs of purchasing their own transporting equipment. Unlike this Manila case, Toyama in Japan has faced issue of decreasing population and aging society. So Toyama set up compact city development, and the policy under this emphasized not only economic growth, but also social and environmental development, especially through local public transport policies that they've achieved multi-benefits. It reduced GHG through public transport system for sure, and increased ridership of especially elderly citizens, as this infrastructure covered improvement with low carriage floors and wheelchair accessibility to the stations. The ridership in result doubled on weekdays, increased by 3 times on weekends. So these types of approach suggests potential of local public transport policies to go beyond emission reductions and create social co-benefits that could provide solutions of how to deliver effectively the interlinked 2030 agenda and Paris Agreement. Another case is on energy creation with women and locals. I've mentioned earlier that Green Climate Fund emphasizes social co-benefits and gender sensitivity from the project proposals to the implementation. And it's because, adverse effects of those climate change fall more heavily on women, especially in developing countries. For instance, poor women and their children suffer the most from household air pollution during cooking and heating processes. So here is climate mitigation project case I can introduce, and which I was involved in, to demonstrate women could have a strong potential to become vital change of agent of change to contribute climate mitigation and achieve co-benefits rather than being passive victim from climate crisis, which was in Dong Hoi, Vietnam. This project focused on engaging women in the biogas supply chain. They were equipped with technical construction and marketing skills to create biodigester supply business, which was a very rare case. As the existing data of Vietnam National Biogas Program indicated, during last decade, there were over 1,700 masons had been trained, but number of female trainers was only 3. So this project initiated trainings with Dong Hoi Women's Union, and women-led biogas mason enterprises were established. And they worked to build 300 new digesters in Dong Hoi, and that reduced about 1,600 tons CO2 equivalent annually. And also, utilization of bioslurry for organic fertilizer replaced the use of chemical fertilizer that contributes to GHG emissions as well. A similar social co-benefits were delivered through implementation of advanced cookstove project in Laos. It was very unique in a way that it empowered those segments of population frequently left out of employment market. Those are disabled women. And if you want to know more about these cases, please visit ACP, Asian Co-Benefit Partnership Good Practice website. The address is here. That map has more cases, and also of these cases more in detail. Okay, so the lessons learned from these cases is creation of multiple benefits is possible with active participation from women and locals, and also they could become agents of change. And when their full engagement or even take a leading role adopted in decision-making process of planning, implementing, evaluating projects, then that deliver much more locally relevant solutions. Okay, and here let me share the last case that expands the scope of inclusivity beyond gender and introduces how to achieve social co-benefits through participatory governance by citizens and for citizens in Seoul. Seoul is densely populated capital city of Republic of Korea that creates high in energy consumption. But for decades last 10 years, Seoul administration aimed to implement innovative environmental policy and energy saving plan, along with full and active participation from citizens based on two-way mutual communication between government and residents in Seoul. One of the outstanding implementation is one less nuclear power plant project that sets ambitious goal of saving 2 million tons of oil equivalent of energy consumption. That equals to the capacity of one nuclear power plant. That was to reflect demand from citizens, those seek for safe and sustainable energy to avoid crisis since Fukushima disaster happened in Japan. And the project covered various initiatives that encourage citizens' involvement, including dissemination of solar PV for individual households and many more small-scale innovations. The role of Seoul government was to support those diverse initiatives through amendment of relevant ordinances and with assistance of implementing teams that facilitate easier access to citizens' participation, and with expansion of stakeholder networks, as well as to encourage private sector's investment that provide technology and production. And the project was highly successful as it achieved its goal 6 months ahead of schedule. One of the essential aspects that delivered this outstanding result is active participations of various groups of citizens in its implementation, as well as in the development of comprehensive plan that had 16 times of meetings among Seoul government expert advisory group and civil society. I think I should deliver a few concluding points. Some overlap, I think, with Zig's statement in his keynote. Okay, so lesson learned from the cases is that co-benefits, social co-benefits, multiple benefits are brought out when there was participatory and inclusive stakeholder engagement in decision-making and implementation. So the key means of implementation to open the potentials of long-lasting programs and policies could be multi-level, multi-benefits approach with active participation of citizens. And as mentioned, biodigester supply case in Donghoi created gender sensitivity on the ground level. And at the government level, related officials started considering policies to provide finance and to support, replicate, and scale up that project. An advanced cookstoves project in Laos worked with Ministry of Natural Resources and Environment and with Lao Women's Union to enhance both agencies' understand co-benefits of gender-responsive approach to climate change mitigation. And after continued dialogue, Lao National Climate Change Action Plan covered gender issues in it. So again, this highlights the importance of working with multi-stakeholders at multi-levels for multi-benefits. The ultimate goal of social co-benefits is to provide benefits to communities, locals, and society, rather than limit to specific sectors or stakeholders. In other words, achieving social co-benefits should be based on multidimensional and multidisciplinary perspective, as vulnerability of local communities and regions is various. Solutions should be varied rather than one fits all. So policymakers need to connect their policymaking to local context, best done by including those communities and citizens, especially from marginalized groups, those affected the most. When voices are heard and reflected into the decision-making and implementation process, achieving co-benefits can deliver long-lasting success for the environmentally sustainable and socially just future. Thank you for your attention.
Thank you, Dr. Sangli. Yeah, three presentations have highlighted the core benefits and co-creation, co-innovation, these aspects. Ultimately, as you summarize, I think this final sentence, final summary was very appropriate, that ultimately the society, the communities, they are the beneficiaries, they are going to get the benefits of all these climate actions, as well as the benefits of sustainable development. So in order to ensure better buy-ins and implementation of these kind of projects and create better awareness as well as engagement with the society and communities, this perspective of co-benefits, they offer, that perspective offers a very useful way of formulating the proposals and projects. If there is any question, we can take one or two questions before I hand it over to Eric. If you have got questions, please take your microphone and raise the question. No, I don't see any questions in the chat box either. So I think we will end the session here, and I will give it back to Eric for the final closing comments. Thank you.
Okay, thank you so much, Sudesh, and thank you very much to all the colleagues that presented in today's workshop. I think we had a very fruitful exchange, and I think we learned a great deal. Some of the key themes that came up in my mind that might be pursued in the context of next year's workshop with the IASA is some of the new technologies that are coming online for co-benefits, particularly hydrogen-based technologies. Some of the institutional and policy issues that arise when trying to achieve co-benefits, and how those institutional issues and policy issues can be incorporated into the modeling. When talking about the urban and regional air pollution linkages, I think there's a lot of scope for taking this concept of regional and circulating ecological sphere and seeing how that could facilitate coordination between urban and nearby areas, how that's being applied in Japan. And I understand that's also being applied in India, in the Nagpur region as well. A few additional themes is there's obviously a lot of work that's being done and could be done on regional cooperation on especially renewable energy policy and climate policy, and what would be the co-benefits of that cooperation. For instance, what would be the co-benefits of a regional emissions trading scheme? And then the last two are taking this idea of co-innovation and applying it to other cases, in particular looking at how this multi-level, multi-stakeholder perspective can enhance this co-innovation process. And then last but not least, I think further detailing some of the new kinds of benefits, whether that be biodiversity or natural resources, or looking a little bit more at circular economy. So some of the new kinds of benefits that come from these approaches, and then also the different types of beneficiaries. Who benefits, I think, is sometimes just as important as how much are the benefits, maybe even more important. So these are some themes we could potentially think about in future years and future workshops, The last point is, I think we could also bring in, I mean, Kojima-san highlighted some additional work that IAS is doing in a second tier of their project, and that could also possibly be featured in future workshops. With that, I would just like to extend our deep and sincere appreciation to the Ministry of Environment Japan for their continued support. I know Matsura-san has been sitting by patiently listening to the workshop, and we also really appreciate the initial introductions from the Ministry of Environment in terms of starting off our workshop. And then last but not least, of course, we greatly appreciate the partnership with all the colleagues here, including, of course, Kyushu University, who has kindly expanded the scope of their workshop, and so that we could cover related themes in one place. So with that, I'd like to turn it over to my colleague, Professor Houman Faraze, to just provide a quick goodbye. So thank you, and thank you so much, everybody. And Dr. Houman, the floor is yours.
Yes, thank you very much, Eric, for the very nice wrap-up session that you provided enough, and clear information about the workshop. I think we had a very good discussion and informative, presentation. I would like to express my sincere thanks to all of the invited speakers for their very fruitful discussion and informative presentation. So, as Eric mentioned, we discussed not only how to quantify co-benefit, but also how to integrate and advance co-benefits. I invite you to, to refer to our book, and we are looking forward to receiving your valuable comments, which enables us to improve the quality of our research and, to find our future research orientation. Once again, thank you very much. I would like to thank my colleagues here at Kyushu University that they help us a lot. Without their support, we couldn't be able to make this workshop. Kawabata-san from QP, Takara-san, Ladan-san, and Sajid-san from our lab, and also other colleagues from QP, and the Kyushu University PR staff for their great support. They are behind the scenes. You cannot see them, and I really appreciate all of your great support. So good night and good evening from Japan, and wish you all the best. Thank you very much.
Thank you very much.